this video, we will solve the questions on mathematical economics that were asked in JAM Economics paper of 2024. The question is, consider an economy with consumption function C is equal to 2 plus 0.5y, where y is the income, the government expenditure is 3, and investment function is being given as I is equal to 4 minus 0.5r, where r is the interest rate. Then the slope of ice curve will be, the options are being given. We need to find out the correct option. Okay, so let us first do one thing. Let us write the equation what we are being given. We are being given the consumption, which is equal to 2 denotes the autonomous consumption, which does not depend upon the level of income, plus we have 0.5 here is the marginal propensity to consume, and y denotes the income. Okay. Sorry. Then also we are being told that government expenditure is here 3, which is autonomous here, and also the investment function is being given as 4 means the autonomous investment, that does not depend upon the rate of interest, minus 0.5 denotes the marginal propensity to interest, and r denotes the rate of interest. These are being given us. We need to find out the slope of i's function. Okay, so first we need to find out the slope of rather the i's curve here. So how do we calculate this i's curve? I's curve shows us goods market equilibrium. Goods market equilibrium. And when is goods market in equilibrium? It is in equilibrium when the total income is equal to the total expenditure, that is the consumption expenditure plus investment expenditure plus government expenditure. Okay, and y will be equal to, so consumption function is being given as 2 plus 0.5y plus investment function is 4 minus 0.5r plus the government expenditure is being given as 3 here. Okay, after that, transposing this to LHS, it will get subtracted. So we have y minus 0.5 y is equal to, so 2 plus 4 is 6 plus 3 is 9. Adding these values, then we have minus 0.5r. Now subtracting 0.5y from y, we will get 0.5y is equal to 9 minus 0.5r. So 0.5 is actually 1 upon 2 y, which is equal to 9 minus 0.5 r. Transposing 2, it will get multiplied, so 9 2s are 18, so y will be equal to 18 minus 2 into 0.5 is 1, so we are left with minus r. Okay, this is actually our i's equation. And what exactly does i's equation tell us? It simply tells us, and let us draw it here, we have the level of income on the horizontal axis, rate of interest on vertical axis, and it has a downward slope because the coefficient of r is negative here. Okay, so i's equation simply tells us, or it shows us as different combinations of rate of interest and level of income where the goods market is in equilibrium. Now the slope of this function will be, this is our i's function, this is our i's function here. Okay, so slope is simply equal to the change in y due to the change in r here. Okay, so differentiating this with respect to r, so the derivative of r is 1, so we are left with minus 1. And let's reciprocate it here, so we can write it here, del r upon del y is equal to, again reciprocating minus 1, it will become minus 1. So the slope of this i's equation comes out to be minus 1. So the correct option should be minus 1 here. Okay, the question is, consider a closed economy ISLM model. The goods and money market equilibrium are respectively given as y is equal to 90 plus 0.8 y subscript d minus 100i plus g. Here y denotes the output, y subscript d denotes the disposable income, I denotes the rate of interest, g is the government expenditure. MS denotes the money supply, so this denotes the goods market equilibrium. Let's write it here. This is the goods market equilibrium, okay? And this equation denotes our money market equilibrium, and it is being given as MS is equal to 750 plus 0.2y minus 260i. MS denotes the money supply here, okay? Where T denotes the tax, which is a function of income, which is equal to 5 plus 0.2y. Money supply is fixed, which is 950, and government expenditure is 300. We need to find out the value of the taxes at equilibrium, okay? Now let's try to solve this. So first thing is, we are being given the goods market equilibrium, okay? Let's write it here. Goods market equilibrium. So we solve this function to derive the is function first. So we have y is equal to 90 plus 0.8. Y subscript d denotes the disposable income. We know that y subscript d, that is disposable income, is equal to total income minus the taxes paid. Okay, so in place of yd we write y minus t. Then we have minus 100i plus government expenditure is 300. So solving this, so we will get 390 here. That is 390 plus 0.8 y minus what is t. So if yd is equal to y minus t, that means y minus the value of t is being given us as 5 plus 0.2 y. So we will get y minus 5 minus 0.2 y in place of y minus t. So in place of t we have this very stuff, that is y minus 5 minus 0.2 y. Then we have minus 100i. So y will be equal to 390 plus 0.8. Subtracting 0.2y from y, we will get 0.8y minus 5 minus 100i. Again solving for y is equal to 390 plus 0.8 into 0.8 is 0.64 y. 0.8 of 5 comes out to be 4. Then we have 100i. That gives us y will be equal to 290 minus 4 comes out to be 390 minus 4 comes out to be 386 plus 0.64 y minus 100i. Okay, so transposing this here, so y minus 0.64 y is equal to 386 minus 100i. So subtracting 0.64 y from y, we will get 0.36 y is equal to 386 minus 100i. Dividing both sides by, rather let's solve this. This comes out to be 36 divided by 100y is equal to 386 minus 100i. Okay. Okay, I will not do that very calculation here. You can do it by yourself. It will get length here. I don't have the space here. So dividing both sides by 0.36, here also by 0.36, here also by 0.36. So we will get y will be equal to 386 divided by 0.36, rather 0.36. It will come out to be 1072.222 minus, here it will come out to be 100 upon 0.36. It comes out to be 277.778i, and this denotes our is function. And what exactly is the is function? Is function, or is curve, if I draw it here, income on the horizontal axis, rate of interest on the vertical axis, it has a negative slope because the rate of interest has negative sign here. So this is our is function. Is curve shows us different combinations of rate of interest and level of income where goods market is in equilibrium. So this is our is function. Similarly, we need to find out the LM function. For that, we need to find out the money market equilibrium. So we are being given the money market equilibrium function is this very stuff. So money supply is being given 950. Let's write here 950 is equal to 750 plus 0.2y minus 260i. Okay, so this denotes 0.2y will be equal to 950 minus 750. It will come out to be 200. Transposing this, it will become plus 260i, or y will be equal to, dividing both sides by 0.2, we will get 200 upon 0.2 comes out to be 1000, plus 260 upon 0.2 comes out to be 1300i. This denotes our LM function. Okay, let's write it here. So we have the LM function. If we have level of income and rate of interest here, it has a positive slope because the coefficient of the interest rate is here positive. Okay, and LM function shows us different combinations of rate of interest and level of income where money market is in equilibrium. Now simultaneous equilibrium requires that the IS and LM functions intersect. Okay, so simultaneous equilibrium requires IS is equal to LM. So we equate these two functions, that is this very function, that is y, since y is equal to this stuff, y is equal to this stuff, LHS is the same, we can equate RHS. That means 1072.222 minus 277.778i. We equate it with this function, that is 1000 plus 1300i. Okay, so we have to find out the value of t. So let us see. First we find out the value of I here, the rate of interest. Okay, so if I transpose this here, it will become 1072.222. If I subtract 1000, it will become 72.22 will be equal to, then we have 277.778. I transposing it here, it will get added. Okay, so it will become 277 plus 1300i, it comes out to be 1577.778i. Okay, so since we need to find out the value of I, we divide both sides by 1577.778, and here we also divide by 1577.778. Okay, so this will get cancelled, we will be left with I will be equal to the value of this very term, it comes out to be 0.046. This is our equilibrium rate of interest. Okay, and what will be then the equilibrium level of income? Simply plug the value of y here, sorry, the rate of interest here in this to find out the equilibrium level of income. Either you put it in this LM function or IS function. So y will be equal to 1000 plus 1300. The value of I is 0.046. So equilibrium level of income will come out to be, when we solve this, it will come out to be 1059.8. Okay, now we got the equilibrium level of income. We can now find out the taxes. Since we know the equilibrium level of tax will be equal to, tax function is being given us as 5 plus 0.2, y is this very stuff, 1059.8. Solving this, we will get this will be equal to 5 plus 211.96, which comes out to be 216.96, and we can, if we round it off to nearest integer, it will become 217. That will be the equilibrium level of tax. The question is, there are two goods X and Y, and there are two consumers A and B in a pure exchange economy. Consumer A and B have the Cobb-Douglas utility function that is being given us. The utility function of person A is 2x raised power 0.4 times y raised power 0.6, and utility function of consumer B is x raised power 0.3 times y raised power 0.7 respectively. Initially, consumer A is endowed with 50 units of good X and 20 units of good Y. Similarly, consumer B is endowed with 50 units of good X and 20 units of good Y. If the unit price of good Y is normalized to unity, that is equal to 1, then the equilibrium unit price of good X is we need to find out. Okay, so this is actually a pure exchange economy question. So what we are being given here, we are being given the utility function of person A is being given by, that is twice x raised power 0.3, and let's write here the subscript A denoting for the consumer A, times y raised power 0.7 A. This is the utility function of consumer A. Similarly, we are being given the utility function of consumer B, that is utility function of consumer B is being given us as x raised power 0.3. Let's write the subscript here, okay, for consumer B, times y raised power 0.7 subscript B. These are the utility functions of two consumers. Okay, also we are being told that consumer A is endowed with 50 units of good X. Okay, let's write the endowment of person A. Okay, what he is endowed with. So let's denote it by W subscript X. That means endowment of good X of consumer A, comma, endowment of good Y by consumer A. And here you can see what is the endowment of we are being given A is endowed with 50 units of good X. So we have 50 units of good X and 20 units of good Y. Okay, so this is the endowment bundle of person A. Similarly, the endowment bundle of consumer B is, let's denote it by WBX. That means units of good X endowed by person B, comma, WBY, the units of good Y endowed by person B. And here we are also being told that B is endowed with 50 units of good X and 20 units of good Y. So let's write it here again. We have 50 units and 20 units of good Y endowed by person B. Okay, now how do we solve this question? Let us first find out the total income of the consumer. Okay, so let me use another color. Okay, what will be the income of the consumer A? Let's write it here. So income of consumer A will be equal to, that will be equal to the price of price of good X times units of good X endowed by person A, plus price of good Y times units of good Y endowed by person A. Okay, this will be the income of the consumer. Here we are assuming that the consumer has no outside income. The endowment actually or his income here. Okay, so what is the price? And we are also being told that price of Y is being normalized to 1. Okay, so can I write the income of consumer A will be equal to, so endowment of good X by A is being given as 50. So in place of WAX I can write 50 times price of X plus endowment of good Y by person A is 20, and price of Y is 1. We know 1 into 20 will be equal to 20. This will be the income for consumer A. Similarly, we need to find out what will be the income for consumer B. Let's denote it by, and let's write it here. So let us say income of consumer B will be equal to, that will be equal to price of X times units of X endowed by person B plus price of Y times units of good Y endowed by person B. So income of person B will be equal to, price of X is not given, so endowment of X is being given by person B as 50. So we write here 50 PX plus price of Y is assumed or normalized to 1. So it is 1, and endowment of good y by person b is 20 here. Okay, I'm just trying to show you how to calculate the computative equilibrium. Okay, so first step is we write the given utility functions and also the initial endowment of the two persons. Next thing is what we do, we find the income of the consumer. That is how do we calculate it. Now next thing is we need to find out the total supply of good X in this economy. Okay, so total supply of good X. What will be the total supply of good X in this economy? And here you can see that will be the endowment of good X and Y held by consumer A and B. Okay, so total supply will be equal to of good X will be equal to the endowment of person A of good X plus the endowment of good X held by person B. That will be equal to W AX plus W BX. Okay, what is WAX? It is 50 plus what is WBX? That is 50 again. So total supply of good X in this economy is equal to 100. Okay. Next thing is we need to find out the demand. Okay, gross demand for good X. And what will be the demand for good X? Demand for good X in this economy. Oh, and what will be the demand for good X? Simply that will be the demand of good X. Okay, that will be, and let's write it. So X will be equal to, how do I write it? So total demand for good X will be equal to demand of good X by consumer A plus the demand of good X by consumer B. This will be the total demand in this economy. Okay, so we need to find out this demand function for good X and demand function for good X by consumer A and demand function for good X by consumer B. So we have to calculate them, these two demand functions first. And how do we calculate the demand functions? You know it pretty well, and let me try to make myself clear here. Okay, so we want to maximize. Okay, I will rub this then. Okay, so let us write the demand function of good X by person A. For that, what will we do? We will maximize the utility function of person A, that is equal to twice X A raised power 0.3 times YA raised power 0.7. Okay, so we have to derive the demand functions of person A and B here subject to the budget. And what will be the budget of the consumer here? For person A, it will be equal to price of X times units of X plus price of Y times units of Y, and here we have XA. Okay, sorry, YA, and it should be equal to the income of the consumer, that is M subscript A. We want to maximize this utility function subject to this budget constraint to derive the demand function for good X by consumer A. So using the tangency condition, we know that at optimality what happens, that is marginal rate of substitution should be equal to the ratio of the prices, that is price of X upon price of Y, which implies MRS is simply marginal utility of X upon marginal utility of good Y, and it should be equal to price of X upon price of Y. MUX means the partial derivative of utility function with respect to good X, and similarly the marginal utility of good Y means the partial derivative of utility function with respect to good Y, and it should be equal to price of X upon price of Y. Okay, Now the derivative of this function with respect to x, what will be? And let's write it here, y properly. So derivative of this function with respect to xa, and let's write the subscript also here. The derivative of this function with respect to x. Okay, so here we have xa raised power 0.3. So 0.3 will become coefficient. And what is 0.3? 0.3 is actually 3 upon 10. Okay, so I can write it. We have twice into 3 upon 10 xa, and exponent is subtracted by 1. So 0.3 minus 1 is minus 0.7. Ya will remain same because we are taking partials. 0.7 divided by dua upon dya. Now this time we take the derivative with respect to y. Okay, so we have twice here again. 0.7 will become coefficient and it will become 7 upon 10. Okay, times x raised power, xa 0.3, ya, the exponent of y will be subtracted by 1.7 minus 1 is minus 0.3. It should be equal to the ratio of the prices, price of x upon price of y. Okay, here we can do some cancellation. 2 and 2 will get cancelled. So we have 3 upon 10 upon 7 upon 10. So 10 also gets cancelled. We are left with 3 upon 7. Okay. If I transpose ya to numerator, it will get multiplied with this ya. Okay, let me explain it here. It will make more sense. So we have here, if I transpose this, and so we have ya 0.7 in the numerator. If I transpose this ya, it will get multiplied, but exponent sign will change. It will become 0.3. Bases are same. Ya 0.7 plus 0.3 comes out to be 1. So we will only get ya in the numerator. And by the same logic, we transpose this xa to denominator. Exponent sign will get changed. It will get multiplied with this x raised power 0.3, and it will add up to 1. Okay, so we will get only xa here is equal to price of x upon price of y. So let us solve it for ya here first. So ya will be equal to, that will be equal to price of x. First to transpose this 7 upon 3. Okay, then if I transpose, it will become 7 upon 3. Then we have price of x upon price of y, and transposing this xa. Okay, next what will we do? We plug this value of ya is equal to this stuff into the budget constraint. Okay, so here we put the value of ya. So what will we get? Let me see if I have space left. Yes, I have the space left. So we will get, I will rub this out obviously because I don't have the space. So we have price of x times units of x a plus price of y times y. In place of ya, we write this stuff, that is 7 upon 3 price of x upon price of y times xa, and it should be equal to the income of the consumer A. Here ya gets cancelled, so we are left with price of x times xa plus 7 price of x into xa divided by 3 should be equal to ma. Okay, so doing cross multiplication, so 3px into xa plus 7px into xa, since these are the same terms, like terms, we can add them up. So this becomes 7, 3 plus 7, it comes out to be 10. So we will get, here we will get 10 upon 3. So xa will be equal to 10 upon 3. I guess I have done somewhere I have done the mistake in calculating. Rather, let me see, 3 upon 7, 7 upon 10. So we have So what was, okay, I have done a horrendous mistake here. Now I know why it's getting, here it is 0.4, I have written 0.3. We have to solve for consumer A here first. Sorry, okay, no problem. So here let us suppose then I have to change all the subscripts here, okay, because the utility function for good person A was this A, and I have written this very stuff, so I have to do it again. Okay, sorry for this mistake. So you can see what happens if mistake happens. So demand function for good A, if we want to calculate, so we want to maximize the utility function. Okay, so to calculate the demand function for good A, we want to maximize the utility function of good A, which is being given as twice x raised power 0.4 y raised power 0.6 subject to the budget. What will be the budget? Price of x times units of good x A plus price of y times units of good y held by, or rather of person A, should be equal to the income of the consumer A. Okay, now we know the first order condition, rather for optimality, requires that we equate the marginal rate of substitution of good x and y, and it should be equal to price of x upon price of y. MRS means the marginal utility of good x upon marginal utility of good y should be equal to price of x upon price of y. Okay, now to calculate the marginal utility of good x, that means the partial derivative of utility function with respect to good x. Okay, and similarly marginal utility of good y means the partial derivative of utility function with respect to good y, and it should be equal to the ratio of the prices, price of x upon price of y here, which implies what is du upon dxa, that is the derivative of this function with respect to xa. Okay, so here you can see we have the derivative of x raised power 0.4 is 0.4 will become coefficient, so 0.4 can be written as 4 upon 10, which becomes 2 upon 5. Okay, so I can write 2 upon 5 here. Then x raised power, and exponent is subtracted by 1, 0.4 minus 1 is minus 0.6, then we have y raised power 0.6, and similarly du upon dya means the partial derivative of this function, and let's write here a and here also a. Okay, the derivative of this function with respect to ya. Again, since we are taking partials with respect to a, so first we have 2, the exponent is 0.6 will become coefficient, 0.6 is equal to 6 upon 10, which is equal to 3 upon 5. Okay, so we have here 3 upon 5, 3 upon 5, then okay, we have then xa raised power 0.4 y, let's write here a and a, ya raised power minus 0.4, because subtracting 1 from 0.6 gives us minus 0.4, and it should be equal to price of x upon price of y. Okay, here we can do some cancellation. This gets cancelled, 5 and 5 gets cancelled, so we are left with 2 upon 3. So 2 upon 3, if I solve this, and you can see if I transpose ya to numerator, what will happen? So we have ya in the numerator as 0.6. If I transpose this ya, it will get multiplied with this ya, but exponent sign will change. If it is minus 0.5, it will become plus 0. Or rather, if it is minus 0.4, it will become plus 0.4. Bases are same, we can add up the exponents. 0.6 plus 0.4 sums up to 1. So we are left with ya only in the numerator. And similarly, if I transpose this term to denominator, exponent sign will change and it will get multiplied with this xa raised power 0.4, and they will sum up to so rather the exponent will sum up to 1, and we will only get xa. Okay, and it should be equal to price of x upon price of y. Solving for ya, that means ya will be equal to, transposing this, it will become 3 upon 2. Okay, if it is 2 upon 3, it will become 3 upon 2. Then we have price of x upon price of y, transposing this xa here. Now what will we do? We simply plug the value of ya into the budget function. Okay, so to find out the demand for good A, so price of x into xa plus price of y, and in place of ya we have this 3 upon 2 price of x upon price of y into xa should be equal to the income of the consumer. Okay, here we can do some cancellation. Y and y gets cancelled. Px into xa, px into xa, they are the same term, so we can, this is okay, let me write it properly. Price of x into units of x, okay, plus then we have 3 px into x divided by 2 is equal to income of person A. Doing cross multiplication, since they are the like terms, we can add them up. So this is 2 px into xa plus 3 px into xa. It sums out to be 5 p x into xa upon 2 is equal to ma. That is the income of the consumer. Okay, I have the space, let me write it here. That means xa will be equal to, that will be equal to, xa will be equal to, so 5 upon 2 will become 2 upon 5. Then we have ma divided by px. Okay, this is the demand function for good x. Okay, itna lamba naam. So demand for good x we calculated is this very stuff, that is equal to 2 upon 5 income of the consumer A upon the price of x. Okay, plus we have to find out the demand function for good B. Okay, for that what we need to do, we need to, and similarly you can see, if we want, since we are interested in equating by competitive equilibrium, what we mean at equilibrium, demand for good x should be equal to supply of good x. We are not solving for good y for the obvious reason, because we are we only need to find out the equilibrium price, and it will be enough to solve for one market here. Okay, so in the same manner we need to calculate the demand for good x by consumer B. For that what will we do? We take the utility function of the consumer B, that is we want to maximize the utility function of I will not explain here, I will do it a bit fast here. Okay, maximize utility of utility function of person B, which is x raised power 0.3 times y raised power 0.7, such that price of x into units of x plus price of y times units of y by person B should be equal to the income of the person B. Okay, so tangency condition requires M or S should be equal to price of x upon price of y, which implies mu x upon mu y is equal to price of x upon price of y. Mu x means the partial derivative of utility function with respect to good x, and du means du upon dxy means the marginal utility of good y. It should be equal to price of x upon price of y. Du upon dxa means the partial derivative of this function with respect to x here. Okay, so 0.3 can be written as 3 upon 10 here. So in place of the exponent of x becomes coefficient, so we have 3 upon 10. Exponent is subtracted by 1.3 minus 1 is minus 0.7, y raised power 0.7 divided by du upon dxb means the derivative of this function. Let's write it here, b and b of this function with respect to b. Okay, so the exponent of y will become coefficient, so 0.7 can be written as 7 upon 10. xb will remain same as 0.3 because we are taking partials. yb 0.7 minus 1 is minus 0.3 should be equal to price of x upon price of y. Here also 10 gets cancelled. Transposing numerators and denominators, we will get 3 upon 7 yb upon xb will be equal to price of x upon price of y. Okay, let's write it here, b and b. solving for yb, it implies yb will be equal to it will become 7 upon 3. Okay, then we have price of x upon price of y. We have xb here, that gives us, okay, now we plug the value of yb here. Sorry, here it is y. Okay, sorry for this mistake again. It is yb. So doing this, what will we get? Price of x into x plus price of y. So yb is equal to 7 upon 3 price of x upon price of y into xb should be equal to the income of the consumer b. So y and y gets cancelled. Again, these are the same terms. So 3 times px, or let's write it here. So 3 px into xb plus 7 px into xb upon 3 is equal to income of the consumer. Doing cross multiplication here. Okay, so there is no 3 here. Okay, so it becomes 3 px, or let's write 3 px into xb plus 7 px into xb divided by 3 is equal to mb. Okay, and let me rub this now. So this is 10, they are the like terms. Px into xb divided by 3 is equal to mb. Solving for xb, so xb will be equal to, so xb will be equal to, so 10 upon 3 will become 3 upon 10, and px will go to the denominator. Okay, and here we have also mb. Okay, I hope I have done it correctly. So what we got 3 upon 10. Okay, mb upon px. Okay, so what is the demand function for good x by consumer b? That will be equal to 3 mb upon 10 px. Okay, now I can rub this out. Now we know that at equilibrium, demand for good x should be equal to supply of good x. Okay, what is the demand for good x? We have calculated it here, you can see, or let's write it here now. I have now the space. So demand for good x is this: 2 upon 5 ma upon px plus 3 mb upon 10 px. And what is the total supply of good x? That is 100. We calculated it, or let's write it in this fashion: wax, or let's cut it short here. So this is here 100. Okay, 100. This denotes the supply, this denotes the demand. Here again we have the same denominator, we can add up the numerator. So we have twice ma plus 3 mb divided by 5. We don't have the same denominator here, sorry. Okay, so first let's make the denominator same. For making denominator same, multiplying this term by 2, the numerator and denominator, so it will become 10 here. Okay, 10 px, then the denominator is same. So we have, now we can add up the numerator. So this becomes 4 ma plus 3 mb upon 10 px. is equal to 100. Now we know that the income of consumer A, we calculated it as 50, so we can write 4. In place of MA, we can write 50. Price of X plus 20. Similarly, for consumer B, we have 50. Price of X plus 20 divided by 10px is equal to 100. Okay, doing the calculation here, let me see if I can do it correctly. So this is 4 5s are 20, so this is 200. Price of X plus 4 2s are 80 plus 3 5s are 150. Price of X plus 3 2s are 60 divided by 10px is equal to 100. That gives us, so 200 plus 200 plus 150, X comes out to be 350 price of X. So this sums up to be 140. Okay, 80 plus 60 upon 10px 100. Okay. So it will become 350 price of X plus 140 is equal to 100 into 10 is 1000 price of X. So transposing this, 1000 price of X minus 350 price of X is equal to 140. So issue 1000 at valu 350 0 0 5 okay, in the TMS in the TMS I he dane 5 in the TMS banya 9 so this is 650 price of X is equal to 140, or price of X will be equal to 140 upon 650. So this gets cancelled, so price of X will be equal to 14 upon 65. Okay, so this will be the price for good X year. The question is, consider the information given in the table below. We are being given 2 years, 2010 and 2020, and their corresponding unemployment rates, number of unemployed and labor force participation rate. We are being told to find out the percentage change in working age population from 2010 to 2020. So first thing is, what will we do? We will find out the working age population for 2010, then we will find working age population for 2020, and then we find out the percentage change. So let's denote working age population by WAP of 2010, and it is equal to, what is the working age population? It is equal to the total labor force divided by labor force participation rate. Okay, so the ratio of the labor force and labor force participation rate gives us the working age population. But what is labor force? Labor force is actually the number of unemployed person plus the number of employed person. Okay, so to find out the labor force, we add the unemployed person plus employed person. But we are being told that the unemployment rate is 15 and number of unemployed is 30. Okay, when we say unemployment rate, we say how many the proportion of unemployed upon the total labor force. Can I write here that means the 15% of labor force is unemployed? Okay, if labor force is equal to unemployed plus employed, okay, this is the definition of the labor force. And we are being told that 15% of labor force is unemployed. So can I write it in this fashion? 15% of labor force is equal to, and what are the number of unemployed? It is 30. So labor force will be equal to 30 divided by 15%. 30 divided by 15, it will give us 200. That means labor force for 2010 will be equal to 200 million. Okay, then labor force participation rate is equal to 200 divided by labor force participation rate for 2010 is 70%. When you solve this, it will come out to be 285.714 million. That means 285 million or is the working age population in 2010. Symmetrically, working age population for 2020 will be equal to the labor force in 2020 divided by the labor force participation rate. Again, we are being told, and we know labor force is equal to unemployed plus employed. So we are being told unemployment rate is 20%, number of unemployed is 50. That means 20% of labor force is unemployed, and which is equal to here 50. So labor force will be equal to 50 divided by 20%, and it will come out to be labor force will be equal to 50 divided by 20%. It will be 50 into 100 divided by 20. So we will get 25 here. 25 into 10 is 250. So 250 million is the labor force in 2020. So we have the labor force is 250 divided by labor force participation rate is being given us as 80%. Solving this, it will give us 312.5 million. Okay, now percentage change. Okay, so percentage change in working age population will be equal to the working age population in 2020 minus the working age population in 2010. When we find out the percentage, so we find out the difference and divide it by the original value. So original is work, and we compare it with the initial value, that is working age population in 2010, and we multiply it by 100 then. So it will come out to be, so we have 312.5 minus 285.714 divided by 285.714. When we multiply it by 100, we will get 9.37 as working age population. Okay, the question is, in a two-player game, player 1 chooses either U or D as strategies, and player 2 can choose either L or R as strategies. Let C be a real number such that the value of C lies between 0 and 1. If the payoff matrix is given by this very stuff, then the number of pure strategy Nash equilibrium in the game is, we need to find out the Nash equilibrium, how many Nash equilibriums are in this game. Okay, so what we are being given, we have player 1 and player 2. Player 1 has two strategies, that is either to go up or down, and player 2 has two strategies also, either to go left or right. Payoff is being shown here, and the payoff shown by the first elements, which are denoted by blue color, denote the payoff for player 1, and the payoff shown by the green color is the payoff for player 2. Okay, also we are being told that the value of, that means we have a real number, what we call C, and it lies between 0 and 1, and we need to find out the Nash equilibrium in this question. Okay, now we can take any value of C which lies between 0 and, which is greater than 0 but less than 1. Let us rewrite this here. Okay, so if I rewrite this here, like this. So we have up and down, that is up, down. Here we have left and right, left and right. Okay, here we have 0, and let's take any number, a number which lies between 0 and 1. Let us take the value, since we are being told that c is greater than 0 and less than 1. Let us take any number. Let c is equal to, let us say 0.2. Okay, we are taking any value which satisfies this very relationship. Okay, if c is equal to 0.2, then what will be here? We will have minus, minus c means minus 0.2. Okay, and here we have 0, and 1 minus c will mean 1 minus 0.2, which is equal to 0.8. Let us write here 0.8. Okay, these are the payoffs for player 1. Now what about the payoff for player 2? Let's write it here. So we have 0 here, here again we have 0, and here minus c, the value of c is 0.2, so we will have minus 0.2, and here 1 minus c will be again 0.8. Okay, I have just taken an arbitrary number for c which satisfies this relationship. So this is player 1, this is player 2. Now what is meant by Nash equilibrium? Nash equilibrium is a set of strategies that players act out with the property that no player benefits from changing their strategy unilaterally. That is, Nash equilibrium is a strategy profile where no player has incentive to unilaterally deviate from their initial strategies. Okay, if they unilaterally change their initial strategy, then we will not have the Nash equilibrium. Or what happens exactly in the Nash equilibrium? In Nash equilibrium, each player chooses the strategy that maximizes his or her expected payoff given the strategies employed by the others. Okay, or simply the strategy, each player chooses its best strategy given other player has also chosen its best strategy. And how do we find out the Nash equilibrium? Let us try to find out. So I have rewritten this here. Now let us suppose that player 1 chooses strategy U. Okay, player 1 goes up. Player 2 has two options, either to go left or right. Left gives him 0 as payoff, right gives him minus 0.2. Since 0 is greater than 0.2, he will choose left. Okay, let's underline it. Now let us suppose that player 1 chooses down. Again, in this case, player 2 has two options, either to go left or right. Left gives him 0 as payoff and right gives him 0.8. Since 0.8 is greater than 0, let's underline this here. Okay, now let us see what happens when player 2 chooses left. Player 1 has two options, either to go up or down. Up gives him 0 payoff, down gives him minus 0.2. Since 0 is greater than minus 0.2, negative, so he will choose up. Again, let us see what happens when player 2 chooses or. Again, player 1 has two options, either to go up or down. Up gives him 0 payoff, down gives him 0.8. Since 0.8 is greater than 0, he will choose 0.8. Now what are the Nash equilibria here? There are two Nash equilibria. Nash equilibrium occurs when both the both the elements in a cell are underlined here. Okay, so in this case we will have two pure strategy Nash equilibrium. Okay, by Nash equilibrium what we mean? Nash equilibrium is a set of strategies that players act out with the property that no player benefits from changing their strategy. I hope the question is, let an inverse demand function for a commodity B. We have the inverse demand function as P is equal to e raised power minus x upon 2, where x is the quantity and P denotes the price. Then when price is 0.5, the consumer surplus is equal to, we need to find out the consumer surplus. Now what we are being given here, we are being given P is equal to e raised power minus x upon 2. Okay, this is our inverse demand function, and we need to find out the consumer surplus. Also we are being told that P is equal to 0.5. okay, first thing is, what will we do in this inverse demand function? Let us take log on both sides. That means ln of P is equal to ln of e raised power, or let's write it here, ln of e raised power minus x upon 2. okay, so ln of P means ln of 0.5, and this can be written as, so if we have ln of x raised power m, it becomes m log x, okay, by the law of logarithm. So here minus x upon 2 times ln of e. okay, now what is ln of 0.5? It is equal to minus 0.69. You can check it on the calculator. Is equal to minus x upon 2. ln of e is equal to 1. okay, because ln of e is in fact equal to 1. Now here minus and minus will get cancelled on both sides. That means x will be equal to, transposing this to, it will get multiplied, it will become 0.69 into 2, which gives us, or let's write it here, x will be equal to 2 into 0.69, it comes out to be 1.38. okay, when price is equal to 0.5, quantity demanded by the consumer is equal to 1.38. Now graphically what exactly is meant by this? Let me see if I have any other marker available here. So okay, so let's draw the graph here. That implies if we have quantity on the horizontal axis and price on the vertical axis, given this inverse demand function, it will look like this. This is our inverse demand function. okay, so this is our demand function. P is equal to e raised power minus x upon 2, where when price is equal to 5, okay, when price is equal to 0.5, okay, it should intersect the x-axis here. okay, let us say it is like this. So when price is 0.5, what is quantity demanded? Quantity demanded is 1.38. Here it is 0. Now what is the consumer surplus? Consumer surplus is the difference between the price that a consumer is willing to pay and the actual price he is paying for a commodity. okay, and graphically it is simply the area which is above the equilibrium price and below the demand curve in this case. okay, so the area of this very shaded region denotes the consumer surplus. Now how do we calculate then the consumer surplus? So consumer surplus will be equal to, first we need to calculate the total expenditure for the consumer. So what is then total expenditure? Total expenditure by the consumer will be equal to price into quantity demanded. So price is 0.5, quantity demanded is 1.38. okay, so this sums up to, so it will again sum up to 0.69. okay, then consumer surplus is simply the definite integral from 0 to equilibrium quantity and the integral of the demand function with respect to x. okay, and graphically it means the area of this whole region. okay, this denotes the area of this whole region up to this. From this we subtract the total expenditure of the consumer. That is, the total expenditure is this very region here. So here we have consumer surplus will be equal to the definite integral from 0 to 1.38, 1.38, and the integral of e raised power minus x upon 2. From this we subtract the total expenditure. Okay, that is the total expenditure is price into x. Price into x. Remember, this is not included in the integral, this p into x. So taking the integral here, consumer surplus will be equal to the integral of e raised power minus x upon 2 comes out to be e raised power minus x upon 2 divided by minus 1 upon 2. Okay, so which will be equal to minus twice e raised power minus x upon 2. So I can write it here. The integral of this will come out to be minus twice e raised power minus x upon 2, and we evaluate it from lower limit to upper limit. Upper limit is 1.38. From this we subtract the total expenditure, that is 0.69. 0.69. Now let's solve this. So consumer surplus will be equal to, so what will we do here? I can rewrite this function like this. Let us see, minus 2 divided by e raised power plus x upon 2, 0 to 1.38 minus 0.69. Okay, I have just transposed this e raised power x minus x upon 2 to denominator, so the exponent sign will get changed. Now first we evaluate it at the upper limit, then subtract and evaluate it at lower limit. Okay, so we have first minus 2 divided by e raised power, in place of x we have 1.38 divided by 2. Okay, so first we evaluated this at upper limit, then we subtract and evaluate it at lower limit. So lower limit will be equal to, first we have minus 2 divided by e raised power, in place of x this time we have 0 upon 2. Okay, from this we subtract the total expenditure 0.69. So we will get minus 2 divided by 1.38 upon 2. It again comes out to be e raised power 0.69. Minus into minus is plus here. We will get here twice e raised power 0 upon 2 will become 0, so it comes out to be anything raised power 0 is equal to 1, so we will get 1 here, then we have minus 0.69. So minus 2 e raised power 0.69, it comes out to be 1.99, plus we have 2 minus 0.69, which results in the consumer surplus will be equal to, so minus 2 upon 1.99, it comes out to be minus 1 upon, minus 1.01. Then let's write this term, or let's write first 2, then we have minus 0.69, which comes out to be equal to, consumer surplus will be equal to minus 1.7. Adding these two, then subtracting plus 2. Let's write it here first, plus 2, that gives us consumer surplus will be equal to 0.3. Okay, so we will get the consumer surplus as 0.3 in this case. Okay, I hope I have done it correctly. Let us see, let me be very certain here. We have 1.01, to this we add 0.69, so 9 plus 1 is 10, this comes out to be 7, so 1.7. Okay, so consumer surplus will be equal to 0.3. This is the consumer surplus here. So consumer surplus is simply the area which is above the equilibrium price and below the demand curve. How do we calculate? First we take the area of this whole region, okay, and this is being denoted by this very interval. From this we subtract this very rectangle, and this is denoted by the total expenditure. When we solve it, we will get the consumer surplus is 0.3. The question is, a consumer's utility function is given by, utility is a function of the two goods x1 and x2, which is equal to 2x1 minus 1 raised power 0.25 times x2 minus 4 raised power 0.75. If the consumer has a total budget of $73 and unit price of good x1 and x2 are $2 and $1 respectively, then the value of x1 plus x2 is, we need to find out the optimal value of x1 and x2 combined. Okay, so what we are being given? We are being given a utility function, that is u is equal to 2x1 minus 1 raised power 0.25. It can be written as 1 upon 4. Okay, then we have x2 minus 4, and in place of 0.75 we can write 3 upon 4, simply changing them into fractions. So the endeavor of the consumer is to maximize this utility. Okay, so maximize utility subject to the given budget constraint. And what is the budget constraint? We are being told price of x is being given as price of x1, and let's write it here p1. Okay, price of x1 is being given us here as $2, and price of x2 is being given us as $1, and income of the consumer is being given us as $73. Okay, so consumer wants to maximize this utility subject to the budget constraint. What is the budget constraint for the consumer? Let's write it here. That will be p1, that means price of good 1 times of units of good 1 plus price of good 2 times units of good 2, that is x2, should be equal to the total budget of the consumer. Okay, p1 is 2, so we can write consumer wants to maximize this utility subject to this budget constraint. That is, in place of p1 we have 2, we write twice x1 plus, in place of p2 we have 1, so we can write x2 is equal to the income of the consumer, that is the budget of the consumer, which is m, and m is equal to 73. Okay, now graphically what exactly is meant by this? So let us say we have good x1 on the horizontal axis, x2 on the vertical axis with the given budget. Okay, let us say this is a budget line of the consumer. With the given budget, consumer wants to reach to the highest possible indifference curve or highest possible utility. Okay, so with the given budget line, consumer wants to reach to the highest possible indifference curve to maximize his utility or satisfaction. Okay, and it happens the optimal value lies at a point where the slope of the indifference curve and the slope of budget line are equal, and it is a point where they are tangent to each other. Okay, so what is the condition for optimality? That is, the marginal rate of substitution between x1 and x2 should be equal to the ratio of the prices, that is p1 upon p2. Now MRS is, as we know, it denotes the slope of the indifference curve. It denotes the slope of indifference curve, and this denotes the slope of BUD budget line. Okay, now what is MRS? As we know, MRS is simply the marginal utility of good 1 upon marginal utility of good 2. So let's calculate them first. Marginal utility of good 1 means the partial derivative of the utility function with respect to x1. Okay, so with this utility, taking partial with respect to x1 will give us, since we are taking the partials with respect to x1, so x1 is here, so it is raised power 1 upon 4. So first we use power function rule. 1 upon 4 will become coefficient, then we have 2x1 minus 1, and then we have then exponent is subtracted by 1, so 1 upon 4 minus 1 comes out to be minus 3 upon 4. Okay, then we have x2 minus 4 raised power 3 upon 4 times the derivative of this. Okay, first we apply the power function rule here, and then we internally differentiate with respect to x1. So here we will get also 2. Okay, similarly, marginal utility of good 2 means the partial derivative of utility function with respect to good x2. So this time taking partials with respect to x2, so x2 is in this here. So first the exponent becomes coefficient, so we will get 3 upon 4. 2x1 minus 1 raised power 1 upon 4 will remain same because we are taking partials with respect to x2. Okay, then we have x2 minus 1 raised power, when we exponent is subtracted by 1, 3 upon 4 minus 1 comes out to be minus 1 upon 4, and the derivative of x2 in the brackets is 1. Okay, here we have 1. Now, as we know, let me see if I have the space left. Yes, I do have. So solving these, mu1 upon mu2 is equal to du upon dx1 divided by du upon dx2. So we divide them with each other, and it should be equal to the ratio of the prices, that is p1 upon p2. p1 is being given us as 2 and p2 is equal to 1. Okay, I have divided mu1 and mu2 here to save the space. So here what will we get? Let us see. First thing is we have 1 upon 4 into, it will get reciprocated, it will become 4 upon 3. Then we have 2x1 minus 1 raised power 1 upon 4. Okay, so let's write it here, 2x1 minus 1 raised power 1 upon 4. And when we transpose this to numerator, okay, so let me rewrite it here, it is getting messy here. So what we will do here, first thing is we transpose this term to denominator and this term to numerator. Okay, and let me explain it here, what I am doing here. When I transpose, let us say this term to numerator, what will happen? It will become x2 minus 1, x2 minus 4 raised power 3 upon 4. Transposing this term, it will become x2. Okay, where is x2 minus 4? Okay, we have here x2 minus 4. Here also it is x2 minus 4. Okay, x2 minus 4. When I transpose this term to numerator, the exponent sign will change, so it will become 1 upon 4. Since bases are same, we can add up the exponent, so it will become x2 minus 4 raised power 1. Okay, so what is happening here? When we solve this stuff, we are getting x2 minus 4, and similarly when we transpose this term to denominator, it will get multiplied with this term and exponents will add up to 1, so we will get 2x1 minus 1. Then we have 1 upon 4 into 4 upon 3 into 2, so this gets cancelled, so it should be equal to 2 upon 1. So also 2 and 2 will get cancelled, then that implies x2 minus 4 upon 2x1 minus 1 is equal to, transposing this, it will become 3, which implies 6x1 minus 3 is equal to x2 minus 4, which implies solving for x1, or let us solve for x2, that transposing this here, so 6x1 minus 4, minus 3 plus 4 becomes minus 3 plus 4 becomes 1. This is x2. Okay, now we plug the value of x2 into the budget constraint. Okay, so we have 2x1 plus x2 is equal to this stuff, 6x1 plus 1 is equal to 73, so we have 6x plus 2x comes out to be 8x1 is equal to, transposing this one, it will get subtracted, 73 minus 1 is 72. Dividing both sides by 8, we will get x1 will be equal to 9. Okay, so the optimal value of x1 is 9. Then the value of x2 will be equal to, plug the value of x2 in this equation, rather plug the value of x1 in this equation to get the value of x2. So x2 will be equal to 6 times the value of x1 is 9 plus 1, which gives us x2 will be equal to, x2 is equal to 9 6 are 54, which is 55. So 54 plus 1 comes out to be 55. Then x1 plus x2 comes out to be 55 plus 9, which comes out to be 64. Okay, so the value of x1 plus x2 at optimal will be equal to 64. The question is, an individual owns a mobile phone valued at 40,000 rupees. The current value of the individual is 2 lakh rupees, including the value of the mobile phone. According to reports, there are 20% chances of mobile phone theft, and an actually fair policy is available to ensure the loss of the mobile phone against theft. The individual's von Neumann-Morgenstern utility of wealth function is being given as, that is, utility of wealth is equal to under root W, where W denotes the wealth. We have to find out the maximum willingness to pay for such an actually fair insurance policy. Okay, so what we are being given here, and let's write it here. We are being given a utility of wealth is equal to under root W. Okay, now let's denote, and let me write it here. Let W naught denotes the initial wealth. Initial wealth. Initial wealth. Okay, and let's denote L as the loss. Okay, then what will be the total wealth of the individual? Wealth of the individual will be equal to the initial wealth. Okay, here we are being told that 20% chances are that mobile phone will get loss, or there will be theft of the mobile phone. That means 80% chances are there will be no loss of the mobile phone. So initial wealth will be equal to W naught, which is the initial wealth, rather the total wealth will be initial wealth with probability of 0.8. okay, with there are 80% chances that there will be no mobile phone theft. That means in case the total wealth of the individual will be the initial wealth. Also there are chances of 20% of theft, and what will be then the wealth of the individual? That will be equal to the initial wealth minus the amount of loss, and its probability is 0.2. okay, 0.2, and we can write it again like this. So that means total wealth of the individual will be equal to W naught is 2000, rather 2 lakh, and probability of having the initial wealth is 0.8 in case of no theft, and W naught minus L means 2 lakh minus 40,000, which comes out to be 1,60,000. okay, there are chances of 20% of mobile phone theft, and in this case the total wealth of the consumer will be equal to the initial wealth minus the loss of the mobile phone. Now we have to find out the maximum willingness to pay for such an actually fair insurance. Okay, by actually fair insurance, what we mean, actually fair insurance is where the premium is equal to the expected loss. Okay, in case of actually fair insurance, the premium paid is equal to expected loss. Expected loss. And what is the expected loss? Expected loss is simply the probability of loss times the size of loss. And in this case, what will be the actually fair premium? So that will be equal to probability of loss is 0.2 and amount of loss is 40,000, which comes out to be P will be equal to Okay, let's denote it by f subscript with the subscript f. So it will be equal to 8,000. Okay, this is the actually fair premium, but we are not interested in finding out the actually fair premium. Okay, we simply say that an insurance policy is actually fair if the premium is equal to the expected loss. Okay, since insurance increases the individual's welfare, he would be willing to pay some price in excess of the actually fair premium to defray the loss or to defray the risk of mobile phone theft. And we need to find out that very actually fair, rather the maximum willing, how much he is willing to pay in excess of the actually fair premium. Okay, for that what will we do? We will equate, and let's write, we will first find out the expected utility, okay, without insurance. Okay, IN uninsured, let us denote it by expected utility without insurance, and we will equate that very thing with the expected utility with insurance. Okay, with insured. Okay, so first thing is we will find out the expected utility without insurance. Okay, so what will be the expected utility without insurance? Let us calculate that. Let us denote it by U, then I naught. Okay, I naught denotes the uninsured here. That will be equal to expected utility. That will be equal to the probability of not getting loss. That means that will be equal to 0.8 times the utility of initial value, that is equal to W naught, plus 0.2 times utility of W naught minus L. Okay, how do we calculate the expected utility? Simply we multiply the events with their respective probabilities. So the event is, we will have 2 lakh rupees, and we multiply it with the corresponding probability. And also we have, since we are trying to find out the expected utility, so it will be equal to the probability of 0.8 times the utility of this 2 lakh plus 0.2, that is the probability of loss, times the utility of the wealth in case of loss. So which will be equal to 0.8, utility of W means utility of 2 lakh here. Okay, plus 0.2, the utility of W naught minus L means the utility of 1,60,000. Okay, which is equal to 0.8. Utility of 2 lakh means, so U of W is equal to under root W, so we will have under root 2 lakh plus 0.2 under root 1,60,000. Okay, solving this we will get 0.8 under root of 2000. When we calculate it, it comes out to be 447.213 plus 0.2 under root of 1,16,000 comes out to be 400. Okay, when we do the addition here, we will get 437.77. This is the utility that the individual is getting if he does not insure. Now we need to equate, we need to find out the utility without insurance. Okay, so let me rub this out. We don't need this very stuff here. So we also find out the utility function with insurance, and let's define it here. Let us suppose, let P be the premium he is willing to pay for insurance. Okay, then what will be the utility with insurance? Okay, so the utility, expected utility with insurance, and let's denote it by E U I. Okay, so expected utility with insurance will be equal to, first, the probability of not happening the event, that means probability of not loss, which is 0.8, times the utility of initial value, that is W naught, minus he has to pay the premium in case whether the theft happens or not, so it will be equal to P. Remember this here. Okay, plus then we are also being told that there is 20% chances of loss, so we write probability of loss times the utility of, and in this case what will be the utility? So we will have the utility of the initial value, okay, minus the loss he incurs, plus the premium he pays, plus the loss he is being compensated for. Okay, let me explain it again. So when he is paying a premium of P, what will be his utility with insurance? That will be equal to 0.8, that is the probability that the theft does not occur, times the utility of the value. What will be the value in this case? That will be equal to the initial value he is having minus the premium he has to pay, whether the loss occurs or not. Okay, plus 0.2 utility of when the loss occurs, probability of loss times, and in this case what will be the value? So value will be equal to W naught, that is initial value, minus this denotes the loss he occurs due to theft. P denotes the premium he has to pay when he takes the premium, and this plus L denotes the compensation for the loss. Okay, so expected utility with insurance will be equal to 0.8 the utility of W naught minus P. Okay, that is 1 is 10, 100,000, 10,000 lakh minus P, plus 0.2, here minus and plus L gets cancelled. Then we have the utility of we have 2 lakh minus P. Okay, since these are the like terms, we can add them up. Okay, 0.8 U plus 0.2 U, it sums up to be U 2000 minus P. Okay, and we can write it utility of this very stuff will be equal to under root, rather 2 lakh minus P. Okay, I am really sorry if if I was not able to explain it perfectly, because there is so much noise, I am getting distracted. Okay, so this denotes the utility without insurance. Now we equate utility without taking insurance with the utility with insurance. Okay, utility with insurance is equal to 1 is 10 is 100,000, 10,000 lakh minus P, and it is equal to the utility without insurance, which is equal to 437.77. okay, so taking this under root here, it will become square. We will have 2 lakh minus P will be equal to 437.77 square, which comes out to be, transposing this P here, so we will get P will be equal to 2 lakh. 2 lakh minus the square of this comes out to be 191,642.537. That means the maximum amount he is willing to pay will be equal to 2 lakh minus this stuff, and it comes out to be 8357. Okay, this is the maximum price, maximum amount he is willing to pay for the actually fair insurance. Okay, the question is, consider the following information about the economy. Consumption function is 250 plus 0.25 y subscript d, where yd denotes the disposable income. Autonomous investment I naught is being given as 100, and government expenditure is 50. Income tax rate, that is denoted by small t, is 20%. We have to find out the equilibrium level of consumption. Okay, so first we know that our national income identity will be equal to, that is total income will be equal to the consumption expenditure plus the investment function, that is the investment expenditure which is autonomous here, plus the government expenditure which is also autonomous here. Okay, also we are being told that the disposable income, as we know, is simply equal to the total income minus the tax that is being paid on that very total income, that is small tax, that denotes the marginal tax rate, times y. Okay, this denotes our disposable income. Using this information we can write, our y will be equal to, what is the consumption function, that is being given us as 250 plus 0.25. so we have y subscript d here, let's write it here, y subscript d plus autonomous investment is 100, let's write it here 100, plus government expenditure is 50. Okay, that implies our total income will be equal to, so we have 250 plus 100 plus 50, so this is 150 plus 250, this sums up to 400 plus 0.25. now we know that total this y subscript d, that is disposable income, is equal to total income minus marginal tax rate times the income here. Okay, so y will be equal to 400 plus 0.25 times y minus ty. So we have y minus, we are being given income tax rate is 20%, and 20% can be written as 0.2, okay, times y. Writing it again, so we have y is equal to 400 plus 0.25. when we subtract 0.2 from 1, so when we subtract 0.2y from y, we are left with 0.8y. okay, that means our y will be equal to 400 plus, now 0.25 times 0.8, it sums up to be, when we multiply this, it becomes 0.2y. okay, that implies y, transposing this 0.2y to LHS, it will become minus 0.2y will be equal to 400 here. Okay, so subtracting 0.2y from y, we are left with 0.8y is equal to 400. So 0.8 can be written as 8 upon 10 y is equal to 400, which implies y will be equal to, transposing 8 upon 10 to RHS, it will get multiplied but reciprocated, so it will become 10 upon 8. So okay, what is 10 upon 8? This is 8 ones are 8, 8 fives are 40, so we have y is equal to 50 into 10, which becomes our equilibrium level of income will be equal to 500. But we are interested in finding out the equilibrium level of consumption. Okay, so we know our consumption function that is being given us as c is equal to 250 plus 0.25 y subscript d. That means c will be equal to 250 plus 0.25, and y subscript d, we know it is equal to y minus ty. Okay, again solving this, so c will be equal to 250 plus 0.25. Now taking y common, or we can write it in this fashion as we have done it here. So we have y minus 0.2y. Okay, so this is c is equal to 250 plus 0.25. So again doing the same steps, subtracting 0.2y from y, we are left with 0.8y. Okay, so consumption will be equal to 250 plus this 0.25 into 8 is 0.2y, and y we have calculated it as 500. So our equilibrium level of consumption will be 250 plus 0.2 into 500, which is equal to c will be equal to, I guess I have dragged this question into that very step, otherwise it is very simple. Y minus ty, if you plug it here you will get the answer. So we have 250 plus 0.2 is 2 upon 10 into 500, so 0 gets cancelled. So consumption will be equal to 250 plus 2 into 50 is 100, which comes out to be 350. Okay, that means the equilibrium level of consumption will be equal to 350. The question is, let the production function be given by yt is equal to at times kt raised power alpha times ht raised power beta times lt raised power 1 minus alpha minus beta, where at a time t, yt denotes the output, this at denotes the level of total factor productivity, kt is the physical capital, ht is the human capital, and lt denotes the labor. The value of alpha is 1 upon 5 and the value of beta is 2 upon 5. If the growth rate of that is output, physical capital, human capital, and labor are being given as a respectively 10%, 5%, 5%, and 10%, we have to find out the growth rate of the AT, that is the growth rate of total factor productivity. Okay, so let's write the equation that is being given us here. What we are being given? We are being given yt, that is the y denotes the output at a time period t is equal to at times kt raised power alpha times ht raised power beta times lt raised power 1 minus alpha minus beta. Okay, also we are being given here, that is the value of alpha is 1 upon 5, the value of beta is being given us as 2 upon 5. Also we are being given here the growth rate of, let's denote it by g subscript y, the growth rate of output is being given us as 10%, the growth rate of g subscript k, that is the growth rate of physical capital is 5%, the growth rate of ht, that is human capital, is being given us as so we have 1, 2, and 3, it is also 5%, and also we are being given the growth rate of labor. Let's denote it by g subscript l, that is being given us as 10%. We are supposed to find out the growth rate of a, that is the growth rate of total factor productivity. Okay, given these variables, let us try to solve this question. So given this production function, let us take log on both sides. That means log of yt will be equal to log of this whole stuff, that is at times kt raised power alpha times ht raised power beta times lt raised power 1 minus alpha minus beta. Okay, and let me be very specific here. Okay, so we know from the law of logarithm, if we have log of a b, it is equal to log of A plus log of B. Okay, and also we know that if we have log of A raised power n, okay, we write it in this fashion, n log A. Okay, using these very formulas here, what will happen? So log of yt will be equal to, so we have first log of at plus log of kt raised power alpha plus log of ht raised power beta plus log of lt raised power 1 minus, let us take minus common here, we are left with alpha plus beta. Okay, using this very formula, then we can rewrite it as log of yt is equal to log of at plus, here alpha becomes coefficient, so we have a times log of kt, using the second notation here, second formula, plus here b becomes the coefficient, we have log of ht plus here this 1 minus alpha plus beta becomes coefficient, we have then log of lt. Okay, let us take differentials on both sides. Okay, differentiating both sides with respect to t. So we have the derivative of log yt will be equal to 1 upon yt times del yt. Okay, similarly log of at will be equal to 1 upon at times del at. Okay, plus the derivative of log kt will be 1 upon kt times del kt. Okay, from the derivative of log of n is equal to 1 upon n. Okay, similarly we have plus beta here, log. Okay, so in the next equation we have beta, the derivative of log ht will be 1 upon ht times del ht. Plus here we have 1 minus alpha plus beta, derivative of lt will be 1 upon lt times del lt. Okay, so let us rewrite it here. Let me see if I have the space here. I don't have the space, so let's write it here. So I write it in this fashion, del yt upon yt is equal to, similarly here I can write del at upon at plus, we have here alpha, the value of alpha is being given us as 1 upon 5, so let's write 1 upon 5 in place of, so I can write here del kt upon kt plus the value of beta is 2 upon 5, let us write it here 2 upon 5. Then we have del ht upon ht. Okay, so del ht upon ht plus, then we have 1 minus alpha plus beta, and let us see what is 1 minus alpha plus beta. So we have 1 minus alpha plus beta, so alpha is 1 upon 5, beta is 2 upon 5, which implies it will become 1 minus, bases are same, we can, sorry, denominator is same, we can add up the numerator, it becomes 2 plus 1 is 3 upon 5. This is equal to, it becomes 2 upon 5. Okay, so this whole 1 minus alpha plus beta sums up to 2 upon 5. So let's write it here, 2 upon 5 times del lt upon lt. Okay, now what is del yt upon yt? It shows, this shows the change in the output divided by original output. Okay, what is the change in output divided by initial output? It denotes the growth rate of y. That means the growth rate of output. Similarly, the change in technology, total factor productivity upon the original. Simple thing, when some function changes and when we divide it by the original function, we get the growth rate. Okay, so del AT upon AT denotes the growth rate of total factor productivity plus 1 upon 5. Del KT upon KT denotes the growth rate of physical capital plus 2 upon 5. Del HT upon HT denotes the growth rate of human capital plus 2 upon 5. Del LT upon LT denotes the growth rate of labor here. Okay, let's denote it by G subscript L. Now we know from the question that growth rate of output is being given us as 10%, so I can write here 10% is equal to growth rate of, and let's write it here, growth rate of total factor productivity that we are supposed to find out. Let's write it as it is, plus 1 upon 5. What is the growth rate of capital? That is 5%. Okay, let's write here 5% plus 2 upon 5. The growth rate of human capital is also 5%. Let's write it here 5% and plus 2 upon 5. The growth rate of labor is 10%. Let's write it here 10%, which implies 10% will be equal to growth rate of total factor productivity plus, so 5 gets cancelled, we are left with 1% here, plus here 5 gets cancelled, or it becomes 5 2s are 10% upon 5% is 2%. Okay, that makes more sense. Plus here 10 2s are 20 upon 4, which, sorry, 20 upon 5, which comes out to be 4% here, and let's write it here 4%. We need to find out the value of total factor productivity. So 10% is equal to GA. So this is this is 7%, which implies growth rate of total factor productivity will be equal to, transposing this 7%, it will get subtracted, it becomes minus 7%. That means growth rate of productivity will be equal to 3%. Okay, so I hope I make myself clear in this video. By total factor productivity, what we mean the Solow residual, the change or the increase in the growth rate that is not explained by these terms, that is by the physical capital, human capital or labor, and which is only explained by this, the state of technology, what we call the total factor productivity, and at times we call it Solow residual. Okay, the question is, suppose the price elasticity of demand is being given us as minus 1 upon 5 and the price elasticity of supply is 2 upon 5. Then the incidence of specific or per unit tax on the firms is equal to, the options are being given, we need to find out the correct option. Okay, so what we are being given, we are being given the elasticity of demand is equal to minus 1 upon 5. Okay, elasticity of supply is being given us as 2 upon 5. Okay, and the incidence of rather we need to find out the tax incidence on the firms. Okay, first we will find out the tax incidence on the buyers. Okay, on the consumers. Okay, that will be equal to, let's write it here, tax incidence on consumers will be equal to, the formula is very simple, that is equal to elasticity of supply upon elasticity of supply minus elasticity of demand. Okay, this is the formula. That is, the elasticity of supply is 2 upon 5. Let's write it here 2 upon 5. Here elasticity of supply again 2 upon 5 minus, then we have elasticity of demand is minus 1 upon 5. Okay, that means a tax incidence on consumers will be equal to 2 upon 5 divided by 2 upon 5 minus into minus is plus. So this is 2 upon 5 plus 1 upon 5, which becomes, we have 2 upon 5 divided by, so this is 3 upon 5 here. So this is equal to 2 upon 5 into 5 upon 3, that is 2 upon 3. Okay, by this what we mean, that means if $1 of specific tax is being imposed, that means consumers will shoulder 2/3 of $1 of tax, and remaining, what is the remaining? If consumers shoulder 2/3 of the $1 of specific tax, that means firms will shoulder 1 minus 2 upon 3, that is that is equal to 1 upon 3. That is, the firms will shoulder 1/3 of the tax. That means the tax incidence on the firms will be equal to 1 upon 3. Very simple. If $1 of specific tax is being imposed, that means 66% of tax will be borne by the consumers, and the remaining 33.33 will be borne by the firms. Okay, so if you are wondering how did I arrive at this very formula, I will put a link in the description box where I have explained this very formula. Okay, where rather I have derived this very formula. That means then the tax incidence on firms will be equal to 1 minus tax incidence on consumers or buyers. So which will be equal to 1 minus, we got here 2 upon 3, which comes out to be 1 upon 3. That means the correct option should be A option. The question is, a firm has a production function that is homogeneous of degree 1 given by Q is equal to 2 under root LK, where Q denotes the output, L and K denotes the units of labor and capital employed. Unit price of labor is $4, unit price of capital is $16. Assuming that there is zero fixed cost, then the total cost, that is the long run cost of producing 10 units of output will be, we need to find out. So since we have to find out the cost here, that means this is a case of cost minimization problem. That means we want to minimize the cost. What is the cost? That is simply the price of labor times units of labor employed plus price of capital times units of capital employed. So we want to minimize this cost subject to the production constraint. What is the production constraint? That is 2 under root LK should be equal to that we are supposed to produce 10 units. So we set this 2 under root LK equal to 10. Now how do we solve this? So let us use the tangency condition here. Okay, first order condition or tangency condition or first order condition for optimization requires that the marginal rate of technical substitution between labor and capital should be equal to price of labor upon price of capital. MRTS is, it is marginal product of labor upon marginal product of capital. It should be equal to price of labor upon price of capital. Price of labor is 4, price of capital is 16. What is MPL? MPL is simply the partial derivative of production function with respect to labor. Okay, so given this production function, its derivative with respect to L will be so we can rewrite it as Q is equal to 2 L to the power 1 upon 2 K to the power 1 upon 2. Okay, for the sake of simplicity, the derivative of this function with respect to L, so the exponent of L becomes coefficient. So we have 2 into 1 upon 2 L raised power. When we subtract 1 from the exponent, it becomes minus 1 upon 2. Then we have K raised power 1 upon 2. 2 and 2 gets cancelled. So we will get K raised power 1 upon 2 divided by L raised power 1 upon 2. This is marginal product of labor. Similarly, we need to find out the marginal product of capital. That is simply the partial derivative of production function with respect to capital this time. So this time we take the partials with respect to k. The exponent of k will become coefficient. So we have 2 into 1 upon 2. It will become coefficient. L raised power 1 upon 2 will remain same because we are taking partials with respect to k. Then k raised power, the exponent of k will become coefficient. So we have 1 upon 2 minus 1. Again it comes out to be minus 1 upon 2. 2 and 2 gets cancelled. So mpk comes out to be, in this case, L raised power 1 upon 2 divided by k raised power. Transposing this to denominator, exponent sign will change. So what is then MRTS is equal to MPL upon MPK. Okay, so MPL upon MPK, in this case we write MPL comes out to be k raised power 1 upon 2 divided by L raised power 1 upon 2. To this we divide the MPK, that is L raised power 1 upon 2 divided by k raised power 1 upon 2. It should be equal to the price ratio. So 4 upon 16 is 1 upon 4. So we will have k raised power 1 upon 2 divided by L raised power 1 upon 2. You know, transposing this to numerator, it will get multiplied but reciprocated. It will become k raised power 1 upon 2 upon L raised power 1 upon 2 should be equal to 1 upon 4. Bases are same, we can add up the exponents here. So 1 upon 2 plus 1 upon 2 becomes 1. So we will get k, and here we will get L. Again base is same, exponent added up is equal to 1 upon 4. Solving for k, k will be equal to, rather L will be equal to 4k here. Okay, cross multiplying, L will be equal to 4k. Now we plug the value of L is equal to 4k into the production constraint. Okay, that means twice in place of L we have 4k raised power 1 upon 2 times k raised power 1 upon 2 is equal to 10. So this becomes 2. So 4 raised power 1 upon 2, it becomes 2. So because we have under root 4 is equal to 2 here, so we will get 2, and we have k raised power 1 upon 2 times k raised power 1 upon 2 is equal to 10. So this becomes 2 2s are 4, and bases are same, exponents again added. So we will get 4 k is equal to 10, which implies k will be equal to 10 upon 4, which comes out to be 5 upon 2. This is the value of k. Okay, k is equal to 5 upon 2. Then what will be the value of L? Simply plug k is equal to 5 upon 2 into this function. So L will be equal to 4 into 5 upon 2. So 2 1s are 2 2s are 4. So L will be equal to 10. Okay. So the value of L comes out to be 10. Then what will be the total cost? Now we know that our cost is equal to, total cost will be equal to price of labor, that is being given us as 4, times units of labor, we calculated it as 10, plus price of capital is 16, times units of capital is 5 upon 2. So 4 10s are 40, here 2 1s are 2, 8s are 16, so 8 5s are 40 again. So total cost will be equal to 80 units. Okay. So in this case, the total cost of producing, rather the total long run cost of producing 10 units will be equal to 80. Question is, consider a production function y is equal to a times log of L plus 1 minus a times log of k. The value of a lies between 0 and 1, and a is not equal to 0.5, where y denotes the output, L is labor, and k is the capital. We have to find out the absolute value of elasticity of substitution of the given production function. Okay, so what is meant by the elasticity of substitution? Elasticity of substitution measures how the capital labor ratio changes relative to the change in the marginal rate of technical substitution between capital and labor. Okay, and the formula is simple, that is elasticity of substitution. Let's denote it by this symbol. It is simply equal to the change in and let me write it here. Elasticity of substitution is equal to the change in the capital labor ratio relative to the change in the marginal rate of technical substitution times, and we know by elasticity we write here into m r ts upon k upon l. Okay, this is the formula for elasticity of substitution. Now here what we need to do then, given this production function, so first we need to find out the marginal rate of technical substitution. So marginal rate of technical substitution between capital and labor is being given as the marginal product of labor upon marginal product of capital, which is simply equal to, we know that marginal product of labor means the partial derivative of the given production function with respect to L, and similarly MPK means the partial derivative of the given production function with respect to K. Okay, so let us take the derivatives here. So del y upon del L is the partial derivative of this function with respect to L. The derivative of L, rather we have first A here, and derivative of log of L is 1 upon L. Okay, this is dy upon dl. Similarly dy upon dl, dy upon dk, the partial derivative of the production function with respect to capital, which is being given as the marginal product of capital, is simply the equal to, we take the partial derivative of this function with respect to k. Since no k is involved in the first term, its derivative is 0. The derivative of, so first we have 1 minus a, and derivative of log of k, as we know, it is equal to 1 upon k. Okay, so what will be then the marginal rate of technical substitution? So m or ts will be equal to the ratio of these two derivatives, that is the marginal product of labor. We calculated it as a upon l, and rather let's write it in this fashion, a into 1 upon l divided by the marginal product of capital is 1 minus a times 1 upon k. Okay, solving this further, we can write it in this fashion, a, or let's write it here, mrts. So m or ts is equal to a upon 1 minus a times, so 1 upon l divided by 1 upon k, it will become k upon l. Okay, so this is our marginal rate of technical substitution. Now what is then so we need to find out this derivative, the derivative of capital labor ratio with respect to derivative of marginal rate of technical substitution here. So let us first take the derivative of the marginal rate of technical substitution. The derivative of marginal rate of technical substitution with respect to the capital labor ratio. Okay, so we differentiate this function with respect to k upon l. Okay, so the derivative of k upon l, since we are taking it as one term here, so its derivative will be equal to 1, so we are left with a upon 1 minus a. Okay, then elasticity of substitution will be equal to, so dk up, rather we need to find out this dkl, k upon l upon dmrts. Okay, let's reciprocate it, so we can write it as del k upon l divided by del mrts. Okay, we are just reciprocating this, so we will get 1 minus a divided by a. Okay, reciprocating both sides, we get this stuff. Now the elasticity of substitution, as we know, will be equal to, and let's write it here, let's write the formula here. So we have the elasticity of substitution is equal to dkl upon dmrts, which is equal to 1 minus a upon a times the mrts. So mrts we calculated it as this very function, that is a divided by 1 minus a divided by capital labor ratio. Okay, divided by k upon l. So here we have mrts is equal to actually k upon L is also here. Okay, so elasticity of substitution is this very derivative which we calculated here as this, so I have written it here, times MRTS. MRTS is this very stuff and I have written it here, divided by capital labor ratio. Okay, so here KL and KL gets cancelled, so we are left with 1 minus A divided by A into, here we are left with A divided by 1 minus A. Okay, this gets cancelled, so elasticity of substitution will be equal to 1. Okay, so this elasticity of substitution measures how the capital labor ratio changes relative to the change in the marginal rate of technical substitution. Okay, I hope the question is, consider the production function is Q is a function of capital and labor which is equal to 2 under root K plus 3 under root L whole square, where Q is the output, K is the capital, L is the labor. If n subscript K and n subscript L denote output elasticities with respect to capital and labor respectively, then the value of n subscript K plus n subscript L is, options are being given, we need to find out the correct option. Okay, so given this production function, if I rewrite it as Q is equal to twice under root K plus 3 under root L whole square, then output elasticity of labor, rather output elasticity of capital is being given by, that is the change in the output due to change in the capital into capital upon output. Simple function, simple logic, like the way in which we compute the price elasticity of demand, in the same fashion we compute the output elasticity of capital here. That is the change in output due to change in the capital times capital upon output. Okay, so first we need to find out this very derivative, that is del Q upon del K. That means the derivative of this function with respect to K. So first we apply the power function rule, 2 becomes coefficient, so we have 2 times 2 under root K plus 3 under root L. Okay, then we multiply it using the chain rule, and internally we differentiate with respect to K again, that is d upon dk of this 2 under root K. Okay, 2 under root K. So what we will be left with, so we have twice 2 under root K plus 3 under root L. What is the derivative of d upon dk? D upon dk of 2 under root K, it can be written as K raised power 1 upon 2. Its derivative will be, so exponent becomes coefficient, so we have 1 upon 2 into 2, K raised power exponent is subtracted by 1, 2 gets cancelled, we are left with K raised power minus 1 upon 2. Okay, and it can be written as 1 upon K under root K. Okay, if I transpose it to the denominator, so here we will get 1 upon under root K. Okay, so let me rub this out now. Then output elasticity of capital will be equal to, so output elasticity of capital will be equal to this derivative which we calculated today as twice 2 under root K plus 3 under root L divided by under root K into K, we have here K, divided by Q. What is Q? Q is this function 2 under root K plus 3 under root L whole square. Okay, now here this and this will get cancelled. One one term, here we have square, here we have only one as the exponent. Okay, that means what will we get? So we will get n subscript K will be equal to, if I rewrite it here, you can see we are left with twice K. Transposing this to what we call numerator, it will become k raised power minus 1 upon 2, okay, and in the denominator we are left with 2 under root k plus 3 under root l only, okay. So bases are same, we can add the exponents, we will get 2 k raised power 1 upon 2, because 1 minus 1 upon 2 is 1 upon 2, divided by 2 under root k plus 3 under root l, okay. So we have 2 k raised power, so it can be written now in this fashion, let us write it in the under root fashion. So we have 2 under root k divided by 2 under root k plus 3 under root l, okay. This is our output elasticity of capital. So let me rub this out. I forgot to mention about the output elasticity of labor that we have to find out. So this is our output elasticity of capital. Similarly, we need to find out the output elasticity of labor, and let us write it here. So output elasticity of labor will be the partial derivative of production function with respect to labor times labor upon output. Same logic here, we need to find out del q upon del L first, okay. So partial derivative of this function with respect to L using the power function rule first. So 2 becomes coefficient 2 under root k plus 3 under root L, and exponent is subtracted by 1, so our exponent is 1. Then we take the derivative with respect to L of 3 under root L. So del q upon del L will be equal to, so here we have twice 2 under root k plus 3 under root L, the derivative of this function, okay, with respect to L. So we can write it in this fashion: 3 L raised power 1 upon 2, its derivative will be 1 upon 2 will become coefficient, so we will have 1 upon 2 into 3 L raised power, and exponent is subtracted by 1. 1 upon 2 minus 1 is minus 1 upon 2, and this can be written as 3 upon 2. Transposing this to the denominator, it will become plus 1 upon 2, which can be written as 2 under root rather let us write it in this fashion: L raised power 1 upon 2, okay. So in this place I can write 3 upon 2, then I have L raised power 1 upon 2, okay. So let me rub this out. Here 2 and 2 will get cancelled. Then what will be the output elasticity of labor? Output elasticity of labor will be equal to this dq upon dl, which we got here 3, we have here 3, then we have 2 under root k plus 3 under root L divided by this L raised power 1 upon 2 into L, okay. L divided by q. Q is this function 2 under root k plus 3 under root L square, okay. Here one term will get cancelled, so we will be, and transposing this to numerator, we will get n subscript L will be equal to, so L into L raised power minus 1 upon 2, when we transpose it will get multiplied, but exponent sign will change, so it will become L raised power 1 upon 2, that is equal to under root L. So we will get here 3 under root L, 3 under root L divided by 2 under root k plus 3 under root L. Now the sum of n k plus n L will be equal to, let us add them up. So here we have 2 under root k, so we have 2 under root k upon 2 under root k plus 3 under root L, plus here we got this 3 under root L upon 2 under root k plus 3 under root L, okay. Here you can see we have the same denominator, we can add up the numerator. Okay, so we can write 2 under root k plus 3 under root L divided by 2 under root k plus 3 under root L. Okay, since numerator and denominator are same, we can cancel them. So the sum of output elasticity of capital and labor should be equal to 1. That means this option should be correct. Our question is, suppose nominal GDP equals 1000 units and money supply equals 250 units. Based on quantity theory of money, the velocity of money equals to options are being given. We need to find out the correct option. Okay, so what does the quantity theory of money tell us? So its equation is pretty simple. That tells us money supply times velocity of money is equal to the price level times the nominal GDP of the economy. Okay, here we are being told that money supply is being given us as 1000 units, and rather the nominal GDP is being given us as 1000 units, and money supply is being given us as 250 units. We are supposed to find out the velocity of money. By velocity of money, what we mean, the speed at which money flows or is exchanged in an economy. We also call it the turnover of money supply. So plugging the values, so we have 250 in place of n times v. We need to find out p is not being given here, so q is equal to 1000 here, which gives us v will be equal to, dividing both sides by 250, so we will get p into 1 is 10 is 100,000 divided by 250. So velocity will be equal to 1000 upon 250, it comes out to be 4. So in this question, since nothing is being told about the price level, so velocity will be equal to 4. So this means option B should be correct option. Question is, consider a hypothetical economy where only apples and oranges are produced for 3 years. So we are being given years 2015, 16 and 17. Prices of apples are 180, 200 and 250 for 3 years, and quantities are 10, 15 and 18. Similarly for oranges, quantity is 5, 12 and 15 for the 3 years, and correspondingly the prices are 200, 300 and 350. We are being given the 4 options and we need to find out which of these options is correct. Okay, so let us see. The first thing is, the first option is the real GDP in 2017, where base year is 2016 is 4250. We need to find out whether this statement is correct or not. Okay, so first thing is, we need to find out the real GDP. And what exactly is the real GDP? Real GDP. So real GDP is simply the current year's quantity, and when we multiply it with base year price, okay, we multiply it base year prices, we get the real GDP. So in the first option, and let's write it here, A, so base year is being given us as 2016. Now what will be then real GDP in 2017? So or GDP for 2017 will be equal to, so we know that real GDP is current year's quantity, and what is the current year? That is the 2017. What are the quantities? That means 18 units of apples, and we multiply it with the base year prices. Since base year is 2016 here in this case, so we multiply it with this 200 first. So we have 18 into 200 plus, then we have what we call for oranges, what is, since we are taking the real GDP for 2017, So 15 units of oranges are produced, and we multiply it with the base year. Base year is 2016 in the first option. So we have 15 into 300, and it sums out to be 8100. So the first option is incorrect. Now comes to the next option, that is B option. Let us see. So real GDP for 2017 is actually 8100. So let us analyze the B option. So for B option, what we are being given, we have to see whether real GDP in 2016 is 3500, and in this case we have the base year is 2015. So we have base year in this case is 2015, and we have to calculate the real GDP for 2016. So real GDP for 2016 will be equal to, as we know, current year's quantity. So current year means 2016. So current year's quantity implies this 15 and this 12. Okay, and we multiply them with base year prices. And what is the base year this time? We have base year as 2015. So we multiply 15 with this 180 and 12 with this 200. So what will be the real GDP? That will be 15 into 180 plus 12 into 200. And in this case it comes out to be 5100. When we multiply this, so this is also incorrect. Next question, rather next option is, that is C option. We are being told to analyze nominal GDP in the year 2015 is 6600. And what is nominal GDP? Nominal GDP is when we multiply current year quantity with current year's prices. And let us find out then nominal GDP. Nominal GDP for the year 2015. And what is for 2015? Current year is 10, and current year quantity is, current year quantity is 10 and current year price is 180. So we have 10 into so we have 10 into 180 plus, for oranges it is 5 into 200, 5 into 200, and it will add up to 2800. Since it is 6600, so this is also incorrect. Now comes the D option. We are being told that price level is measured by GDP deflator increased in 2017 as compared to 2016. Okay, let us see. So for this, what we need to do, we need to find out the GDP deflator for 2017 and 2016 with base year 2016. Okay, let us first find out what is meant by GDP deflator. GDP deflator is actually equal to the nominal GDP divided by real GDP into 100. Okay, so let's find out the GDP deflator for 2000. GDP deflator for 2017. Okay, so for this we need to find out the nominal GDP for 2017. So first we found nominal GDP for 2017. So current year quantity times current year prices. So we have 18 into 250, 18 into 250 plus 15 into 350. Okay, and we are calculating it for 2017, so it will come out to be 10650. And what is real GDP for 2017? So current year quantity with base year quantity. So what is the base year? Base year is 2016. and we need to find out for 2017. So again 18 into 200, 18 into 200 plus 15 into 300, 15 into 300. So which will come out to be, when we multiply, 8100. That means, and let me write it here, I guess I have the space left, that is GDP deflator, okay, GDP deflator for 2017 will be equal to nominal GDP, which is 10650, divided by real GDP is 8100. To this we multiply by 100. When you solve this, we will get 131.48. This is the deflator value for 2007, and we need to compare it with the deflator value of 2016. So for the 2016, first we need to find out the nominal GDP for 2016. So we multiply current year quantity with current year price, that is 15 into 200, 15 into 200 plus 12 into 300, 12 into 300. So we are calculating it for 2016. So it will come out to be 6600, and we need to calculate real GDP for 2016 also. So what is that? Is also current year quantity with base year quantity. Since current and base year quantity, so since we have to calculate the GDP deflator for 2016 and base year is also 2016, then what will be the current year quantity? That will be equal to 15 into what is the base year price, that is 200, because base year is in fact 2016, which is equal to 200 plus current year quantity, that is 12 into base year quantity. Since current year and base year quantities are same, it will be equal to, that is the nominal GDP will be equal to real GDP when both current year and base year are same. So doing this calculation, again we will get 6600. So what is then the GDP deflator for 2016? It is equal to nominal GDP, which we got 6600 divided by 66. Real GDP is again 00 into 100. So we will get 100. The question was telling us that price level, since a GDP deflator actually measures the price level, it says the price level as measured by GDP deflator has increased in 2017 as compared to 2016. So in 2016 price level was 100. In 2017 it increased to 131.48. Here you can see it has increased from 100 to 131 from 2016 to 2017. That means the correct option is D option. Question is, in a two-player game, player 1 can choose either M or N as strategies. Player 2 can choose either X, Y or Z as strategies. The payoff matrix is as follows. Okay, we have player 1 and player 2. The strategy profile for player 1 is M and N, and for player 2 he has 3 strategies, X, Y and Z. Okay, red color elements in each cell denote the payoff for player 1, and this is green color elements denote the payoff for player 2. Okay, we need to find out the strategy profile that survives iterated elimination of strictly dominated strategies. By iterated elimination of strictly dominated strategies, what is meant by this? By IESDS, what we mean, it is a technique for solving games that involve iteratively removing the dominated strategies. Okay, and I will explain here. Let us first explain the dominance here. What is meant by dominance? Okay, let us take simple example. Let us say we have a person or player. He has two strategies, R and S. Okay, strategy R gives him a 5 and 6 as payoff. Okay, compared with another player. I am not writing the another player's payoff here, but for the sake of simplicity, I am saying we have player 1. He has two strategies, R and S. R has the payoff of 5 and 6, and S has a payoff of 2 and 1. Okay, here you can see the strategy R, playing strategy R is always better than playing strategy S, because R is better, 5 is better than 2 and 6 is better than 1. So in this case, what we call R is strictly dominant strategy. If R is strictly dominant strategy, that means this S is strictly dominated strategy. Okay, so not to get confused, dominated means that means it is less preferred here, okay, compared to dominant. Okay, if R is dominant, a strictly dominant strategy, that means S is strictly dominated strategy. Okay, so it was necessary to explain the dominance here. Okay, now we need to solve this question by eliminating any strictly dominated strategy, and we need to find out whether we have the strictly dominated strategies here or not. Okay, so let's take the perspective from player 1, and I'm asking a question, a simple question here. Does player 1, okay, always choose M? Okay, if yes, then we say M is strictly dominant strategy. Okay, by dominance what we mean, I can also explain it in this way, that dominance occur when one strategy is better than another strategy for one player, no matter how the opponent player plays. Okay, the question I am asking to myself is, does player 1 always choose M? If yes, then we say M is dominant strategy, and it also implies then, if M is dominant strategy, that means N is dominated strategy. Okay, I have explained to you about the dominant and dominated here. Okay, if no, then we say M is not a dominant strategy. And let us see here. So what happens if player X, and I am asking the question, does player 1 always choose M? Let us see. So if player X, sorry for the mistake, if player 2 chooses X as strategy, what will player 1 choose? Obviously he will choose 3 compared to 0, That means he will play M compared to N, because M gives him 3 payoff, N gives him 0 payoff. So he will play. Okay, no problem up to this. But what happens when player 2 chooses Y? Here you can see. So when player 2 was choosing X, player 1 was choosing M. So that was right. Now when player 2 chooses Y, does player 1 again chooses M? Let me repeat. Okay. Does player 1 choose M again when player 2 chooses Y? Let us see. When player 2 chooses Y, player 1 will choose to play N, because N gives him greater payoff. That is, N gives him 1 payoff, but M gives him 0 payoff. And here you can see he changes his strategy. He is not always playing M strategy regardless what player 2 is playing. So can we say in this case that our answer is no? Okay, so does player 1 always choose M? No. Okay, and by the same logic, does player 1 always choose N? Let us see. If player 2 chooses X, player 1 will choose to play M. Okay, in the first place it gets vanished. It is not choosing N always. So can we say, and if I write here, can I write for player 1 neither M nor N is strictly dominated strategy. Okay, let's take this question from the perspective of player 2. Okay, let me first sort them up. So I am asking the question. Let us see what happens for player 2 now. Does player 2 always choose a specific strategy compared to other strategy? Okay, let's compare here two strategies. I am comparing strategy X and strategy Z. Okay, and here I ask a question. Does player 2 always choose Z? Okay, I am comparing strategy Z with strategy X. Let us leave this strategy Y aside for the moment. Does player 2 always choose Z? Okay, if yes, we say it is strictly dominant strategy. That implies compared to X. Okay, that means X is strictly dominated strategy. If no, we know that then it's not the case that S is strictly dominant strategy. Now let us see what happens when player 1 chooses M. We are comparing strategy X with strategy Z. When player 1 chooses strategy M, player 2 will choose to play strategy Z, because Z gives him 2 payoff, X gives him 1 payoff. Since 2 is greater than 1, so he will choose 2. Okay, so correctly, when player 1 chooses M, player 2 chooses Z. Now what happens when player 1 chooses N? What happens here? Does player 2 always choose Z here again? Let us see. So when player 1 chooses N, player 2, you can see we have to compare these two things. Again, for player 2, it is better to play Z because Z gives him 1 payoff, X gives him 0 payoff. So in this case, we can say that Z is dominant, strictly dominant strategy, or we say that X is dominated by Z, or in other words, we say X is strictly dominated strategy. Okay, and let's write it here. So for player 2, okay, for player 2, and here we can see X is strictly dominated strategy, or we say playing X is strictly dominated by Z. Okay, so this iterated elimination of strictly dominated strategy means we have to then eliminate the strictly dominated strategy. Okay, let's write it here, dominated strategy. Okay, now we know that player 2 being rational, okay, we assume in this case, okay, in iterated elimination of strictly dominated strategies, it is assumed that both the players are rational and each player knows that the rest of the players are also rational. Okay, now here if player 1 knows that player 2 is rational, then player 1 can eliminate X from the player 2 strategy space. Okay, that means we can remove this, this column from this, because as we have seen, X is strictly dominated strategy. Okay, now what will be our table now? Let us again form the same table. Okay, so we have player 1. Player 1 has again two options, M and N, and we have player 2. He has this time only two options left, that is playing Y or Z. And here we have 0 1, we have 0 1 and -1 5, -1 and 0.5. These are the payoffs for player 1. And for Y we have 0 3, 0 3 and 2 1. Okay, same process we apply here. Our endeavor is to remove iteratively the strictly dominated strategies. Okay, I will not explain here, it will get now lengthy. Again, let us take player 1 into consideration. Does player 1 always choose M? Here, whatever player 2 chooses, let us see. So the question is, does player 1 always choose M? Let us see. So if player 2 chooses Y, player 1 can choose either 0 or 1, so he will always, okay, let me see if I have correctly drawn it here. So player 1 will choose, okay, I am getting confused. The question is, does player 1 choose M? Now let us see. If player 2 plays Y, player 1 will choose N. Okay, so M cannot be a dominant strategy right away. Let us see, does player 1 always choose N? Let us see here. So when player 2 plays Y, player 1 will play N, because 1 is greater than 0. Does here also this happen? When player 2 plays Z, does player 2 again chooses N? Yes, obviously 0.5 is greater than -1. So here we can see that for player 1, M is dominated. Rather, M is strictly dominated strategy. And it is another meaning is that N is dominant strategy. Our endeavor is to, delete or eliminate the strictly dominated strategy. Let me explain it again. The question is, does player 1 always play N, whatever player 2 plays, whether Y or Z? Here we have seen, if player 2 chooses Y, player 1 will always choose N. If player 2 chooses Z, player 1 will always choose N. So we say that M is dominated by N. That means M is strictly dominated strategy. Okay. So in this case, what will we do? We will, delete this row. Okay. So our endeavor is to eliminate the strictly dominated strategies here. So what will be our next table? Next table will be then we are left with. So इस हिसाब से मेरा कितना हुआ? Let us see. So we have Y and Z. Y and Z are there, and M is being taken away. Okay, and let B. So we have N strategy left for player 1, and for player 2 we have Y and Z. The payoffs are again, okay, let me use the proper color here. I know it's getting lengthy, but I just want to make sure that I am pretty much more clear to you. Okay, so we are left with N, and let's denote N by this color, Y and Z with Y, Z. So we are left with 1 and 0.5. For this we are left with 3 and 1. Now here player 1 has only one strategy to play N. Okay, what about player 2? So here we can see player 1 plays N. For player 2, Y is better than, rather Y is strictly dominated here or not? So for player 1 has only one strategy N. Okay, what about when player 1 plays N? Player 2 will compare the payoff between 3 and 1. Obviously playing Y gives him more payoff than playing 1. That means player 2 will, or let's write here, for player 2, Z is strictly dominated strategy. Okay, here you can see. So Z is being dominated by this Y. Okay, so we will remove this very strategy also, this profile also. Now what we are being left with? We are being left with only this very strategy, that is player 2 playing Y and player 1 playing N, and their payoffs are 1 and 3. That means and the strategy profile that survives iterated elimination of strictly dominated strategies is N, Y. Okay, I hope is The linear system of equations x plus y is equal to 3 and another equation is x plus k square minus 8 times y is equal to k for k is a real number has no solution for k is equal to what? We need to find out the value of k for which the given system of equations have no solution. Okay, so first thing is we write the given system of equations in matrix form. Okay, so in matrix form that is a into x is equal to b. A denotes the coefficient matrix, and let me write it here. The coefficients of x's and y's, and x denotes the solution vector that we need to find out the value of x and y, and b is the vector of constant terms. So what is our coefficient, rather the coefficient matrix? That is the coefficient of x's in the two equations is 1 and 1, and the coefficients of y's, you can see the coefficient of y in the first equation is 1 and the coefficient of y in the second equation is k square minus 8. This is our coefficient matrix. To this we multiply the solution vector, that is x and y. This is called solution vector, and it should be equal to the vector of constant terms, which is 3 and k. Okay, so 3 and k denote the vector of constant terms. So we have written the given system of equations in matrix form. So we will be applying here Cramer's rule, and I will explain how do we find out the value of k for which the given system of equations have no solution. Okay, if we apply Cramer's rule, okay, Cramer's rule, first thing is to apply Cramer's rule, what will we do? We first find out the determinant of a. Okay, so here what is the determinant of a? So we multiply these two elements first, so that is k square minus 8, that is 1 into k square minus 8. From this we subtract the product of these two elements. Okay, let us say this is the determinant of a. Then to find out the value of x, we form a new matrix. Okay, I'm just trying to show how do we apply Cramer's rule, then I will apply, explain how to get the zero solution. Sorry, this the value of k for which the given system of equation have no solution. So to find out the value of x, okay, what we do, we form a new matrix A1 such that we replace the first column of the coefficient matrix with the vector of constant terms. So we have in place of 1 1 we have 3k, then we have 1 k square minus 8. Okay, similarly to find out the value of y, okay, then let me write it here. Then what will be the value of x, which implies x will be equal to the determinant of a1, and let me write it here, only a1, I have not taken the determinant here, divided by the determinant of the coefficient matrix. In the same manner, to find out the value of y, what will we do? We form a new matrix. Okay, to find out the value of x, we replace the first column. To find out the value of y, we replace the second column. So we have 1 1 1 1 first, then we have in place of this we write 3k. Okay, 3k, then the value of y will be equal to the determinant of this new matrix A2 divided by coefficient matrix. Okay, this is how do we apply the Cramer's rule. Now let us see what the question says and what this determinant plays. How does the determinant plays the role, the determinant of the coefficient matrix? Now if ax is equal to b, here we have written in this fashion, and if the determinant of the coefficient matrix is not equal to 0, in this case we have a unique solution. Okay, but if the determinant of the coefficient matrix is 0, then we have two possibilities. If at least one numerator determinant is 0, we have infinitely many solutions. The thing is that, so let us say this is numerator determinant, and in this case we have this numerator determinant. If the determinant of a1 is equal to 0, or if the determinant of a2 is equal to 0, in this case we will have infinitely many solutions. Okay, if none of the numerator determinant is 0, if both a1 and a2 their determinant are not equal to 0, then in this case we have no solution. Okay, now let's first try to find out. First thing is the determinant should be equal to 0, so we set this equal to 0, the determinant of the coefficient matrix equal to 0. When it is equal to 0, then what happens? So we have k square will be equal to 9, which implies k will be equal to plus minus 3. Here you can see simple thing, which implies k is equal to 3, and again we get two values for k. Okay, k is either 3 or k is equal to minus 3. Okay, now when k is equal to 3, we are just trying to find out the case for no solution. When k is equal to 3, then what is the determinant of a1? So when k is equal to 3, let us find out the determinant of this. So how do we find determinant? We multiply these two elements first. So we have 3 into k square minus 3 8s are 24. From this we subtract k. So when k is equal to 3, that means 3 into 3 square minus 24 minus 3. So this is 9 3s are 27 minus 27, which is equal to 0. So when k is equal to 3, a1 comes out to be 0. That means at least one numerator determinant is 0 here. So when k is equal to 3, we will get infinitely many solutions. Okay, so k cannot be equal to 3 for no solution. Then when k is equal to minus 3, so what will be the determinant of a1? Okay, we don't need to check for a2 here, because since the determinant of a1 comes out to be 0, it is enough to prove that we will have infinitely many solutions. Now let us check for when k is equal to 3, minus 3 rather. So what will be the determinant in this case? Again, so determinant is equal to, we have 3k square minus 24 minus k. So in place of k we have this time minus 3. So we have minus 3 square minus 24 minus, then we have in place of k we have minus 3. So here you can see 3 3s are 9 3s are 27 minus 24 plus 9. Okay, here it comes out to be am I doing it correctly or not? So we have 27 so now I guess it is equal to 11, and it is not equal to 0 here. Here we see that a1 is equal to 11, which is not equal to 0, and we have to see for a2 also. Okay, so what will be a2? When k is equal to minus 3, let's take the determinant of a2. So the determinant of a2 will be equal to, multiplying these two elements first we get k, then we subtract and multiply these two elements minus 3. So we get minus 3 and minus 3. So a2 is equal to minus 6, which is also not equal to 0. So both conditions are satisfied when k is equal to minus 3. That implies, first thing is we set the coefficient matrix equal to 0, and here we got two values for k, that is k is equal to 3 and minus 3. And now to check which of these two values of k give us no solution, we have to form the new matrices a1 and a2 and take their determinant. When k is equal to 3, the numerator determinant of a1 comes out to be 0. So we can say that when a1 is equal to 0, so at least one of the numerator determinant is 0, so it will give us infinitely many solutions. So this is not our headache. We need to find out when it will give us no solution. So we switch from k is equal to 3 to k is equal to minus 3 to check. When k is equal to minus 3, we can see the determinant of a1, which is a numerator determinant, it is not equal to 0. And similarly we check for a2. Okay, here you can see a2 also comes out to be is not equal to 0 when k is equal to minus 3. That means the system of equations will have no solution only when the value of k is -3. So here we have -3. The question is, consider the following three utility functions. We have f is a utility function which is equal to 4x1 plus 2x2. x1 and x2 denote the two goods. And we have another utility function, that is g is equal to minimum of 4x1 comma 2x2. And another utility function is as h is equal to under root x1 plus x2, where x1 and x2 are two goods available at a unit price of p1 and p2 respectively. We are being given four statements and we need to find which of the following is or correct. Okay, there can be one statement correct or more than one statement correct. We need to find out that very stuff. Okay, so let us see what we are being given. We have the three different utility functions and let me write them here. So we have first utility function f is equal to 4x1 plus 2x2. Okay, this is the first utility function, which is a linear utility function in x1 and x2. Okay, and this utility function is for the substitutes. Okay, when we have the two goods, substitutes of each other, we have this kind of linear utility function. Another function is, that is g is equal to minimum of 4x1 comma 2x2. Okay, this kind of utility function we call the perfect complementary utility functions, where the two goods are consumed in a fixed proportion. We also call this the Leontief utility function. And third one is being given us as h is equal to under root of x1 plus x2. And this is our quasi-linear utility function. A utility function in which there is a property that the marginal rate of substitution between these two goods depend only on one good. And I will explain all this stuff in detail here. Okay, so bear with me. So let's take the first statement. We are being told that the marginal rate of substitution is -1, -2 and -0.5 x1 for utility functions f, g and h respectively. Okay, we are being told that the MRS of this utility function is -1, MRS of this utility function is -2 and MRS of this quasi-linear utility function is this very stuff, -0.5 under root x1. Okay, so I will explain all the terms here in detail. Okay, so let's take the first utility function. What is the marginal, given this utility function, what is marginal rate of substitution between good 1 and good 2? It is simply equal to the ratio of the marginal utility of good 1 upon marginal utility of good 2, which is simple, the partial derivative of utility function with respect to good x1 divided by the partial derivative of the given utility function with respect to good x2. And here you can see, and it is actually negative. Okay, marginal rate of substitution is in fact negative. And let us see what comes out here. The derivative of this function with respect to x1 will be equal to 1. So we are left here only 4 here. Okay, since we are taking partials, and the derivative of this function with respect to x2 will be equal to 2. So we got 4 divided by 2, which is equal to -2. Okay, so first thing is MRS is -2 and not -1 for the first utility function. Okay, but I need to, for the sake of learning, I will derive the marginal rate of substitution for each term. Otherwise, I can say that the first statement is not correct because the first part of this is, incorrect, because MRS is here -1, here it is -2. That means the whole statement is incorrect. But I will explain the MRS for other terms also. Okay, then we have this, what we call the Leontief utility function or perfect complementary utility function, a function in which two goods are consumed in a fixed proportion. Okay, and what is the MRS here? Let us see. If I draw the and let me draw it here for the sake of simplicity. And let me see if I have the duster available here. Okay, I have the Java. So in case of this perfect complementary utility function, since this is not a differentiable utility function, its MRS is not defined at a point of king. That means we know that for perfect complementary utility function, let us say this is x1 and x2. Okay, the isoquant, okay, what should I call? No, isoquant not. I will say the indifference curve in this case. The indifference curve of a Leontief utility function is L-shaped and it is not differentiable, okay, at a point of king. Then what by this what we mean? Then what will be the MRS of this very utility function? Let us see. Let us say we have the utility fixed at 10. Okay, let us say this is our utility function. We have two goods x1 and x2, and let us see first the MRS of the vertical portion. And what is MRS here? MRS will be equal to MRS is actually the slope of the MRS is in fact here what we are actually calculating, the slope. And here the slope of this indifference curve on vertical section will be equal to, let us say we have x1 is, let us say here it is 2, and here let us say it is also 2. Okay, now when x2 is increased to 3 and x1 is not increased at all, it says this: if x1 is equal to 2 and x2 is equal to 2, our utility is 10. Okay, so we are using these two what we call the two goods in a fixed proportion. Let us see what happens if we fix x1 at 2 and increase x2 to 3. Our utility will again remain same. That is, utility will be equal to 10. Why? Because we are consuming the two goods in a fixed proportion. Changing the amount of one good unilaterally will not increase the utility of the consumer at all in this case. And what will be the MRS of the vertical section? That will be equal to change in x2 upon change in x1. So what is the change in x2? That is from 2 to 3. That is the change in x2 is, let us say it is 2 minus 3. So 2 to 3 it is rather 1. And what is the change in x1? The change in x1 is nothing. It is 2 minus 2, which is 0. So at the vertical portion, MRS is infinity. And what about the horizontal portion? What is the the MRS of this very indifference curve? Let us see here. Let us say x2 is fixed at 2 and we increase the amount of x1 to, let us say, 3. And in this case, what will be MRS then? That will be equal to change in x2 divided by change in x1. What is the change in x2? Since we are not increasing the units of x2, it is only 2. And what is the change in, rather, the change in x2 is 0 here. Okay, we are not increasing the units of x2. And what is the change in x1? It is 3 minus 2, which is 1. So for this 0 upon 1 is equal to 0. For this horizontal portion, MRS will be equal to 0. Okay, that means for this utility function I have just taken a simple example to explain the MRS of this perfect complementary utility function. And I can say that MRS can take two values. that is infinity when we are on this side and 0 on the horizontal axis. And we can also take this utility function and solve for, that is, I have taken a hypothetical example here. If I take this very example also, I can prove the very stuff here. That means we have g is equal to minimum of 4x1 comma 2x2. And to draw the indifference curve, we first fix the level of utility. Let us say let us say in place of g we have, that is minimum of, in place of g we have, let us say we have 12. Okay, so 12 is equal to minimum of 4x1 comma x2 here. Okay, to draw the indifference curve, what will we do? We equate 4x1 with the given level of utility first. That means 4x1 is equal to 12. That gives us x1 will be equal to 12 divided by 4, which is equal to 3. Similarly, then we equate 12 with 2x2. So 2x2 is equal to 12, which implies x2 will be equal to 6. Okay, so when we have x1 and x2, when the x1 is 3, let us say here it is 3, and x2 is 6, let us say it is 6. So this point denotes the optimal bundle here. And here you can see it will look like this. We will have this kind of indifference curve when our utility is fixed at 12. Okay, then what happens here? What is what we call, so our utility is 12 when x1 is 3, x2 is 6. Okay, now when x1 is increased to, let us say, to 4, x2 is fixed, then what will be our utility? So simply we plug, our utility will be equal to, u will be equal to minimum of the values, that is 4 into the value of x1 is 4, the value of x2 is 6, so 6 into 2 is 12, and here you can see u will be equal to minimum of the two values, that is 16 and 12. Here you can see, so our utility is again same, that is equal to 12. So changing only one good unilaterally does not increase the utility at all. Okay, so I was saying that when x1 was 3, when it was increased to 4, our utility remained same, that is the minimum of 16 and 12 is 12. Okay, and here you can also check for when we increase the utility of, first we have 6, then let us say we increase it to 7. Again here you can see the utility will remain same, that is when x1 is 7 and rather when x2 is 7. Okay, when x1 is, let's first write the value of x1 fixed at 3 and x2 is increased to 7. In this case, what will be our utility? That will be minimum of, so we have 4 into 3, the value of x1 comma 7 into x2 is, we have 2 into 7, 2 into the value of x2 is 7. So here you can see we have minimum of 12 and 7 2s are 14. Again our utility remains same, which is 12 here, when we increase only one good unilaterally here without increasing the other good in the fixed proportion here. Now here you can see the MRS of this vertical section. Okay, so MRS of vertical section will be equal to change in x2 divided by change in x1. Okay, so change in x2 is from 6 to 7, so it has increased by 1 unit, and change in x1 is, we are not changing x1 at all here, so it is 0. Change in x1 is 0, so it is infinity on this side, and on this side here you can see MRS of the horizontal section will be equal to change in x2 divided by change in x1. So what is the change in x2? Since we are fixing the value of x2 at 6, so change in x2 is 0. x1 has increased from 3 to 4, which is equal to 1. So we got 0 MRS on the horizontal axis and infinity MRS on vertical section. That means the MRS is not defined at this point, okay, because MRS denotes the slope of the indifference curve, and at this point we have a kink, only simple point that we cannot find out the slope of a kink. Okay, so -2 cannot be MRS here. That is what I was trying to explain here for the perfect complementary utility function. Now we have another utility function which is quasi-linear. Okay, we say a utility function, and let me write it here. A utility function. Let us say I am saying a utility function. Say we have a utility function of form x1 comma x2, which is equal to v x1 plus x2. That means v is a function, that means, and x2 is linear here. Okay, we say this kind of utility function, a utility function of this form, has a property that it is M or S, that is the MRS between x1 and x2 depends only on the x1, okay, and not on this x2. And let's write here where v is an increasing function, that means the derivative of v with respect to x1 is positive. We say that very kind of utility function is a quasi-linear utility function. And what is the MRS? Let us try to find out the marginal MRS of this function, that is marginal utility of good 1 upon marginal utility of good 2, which will be equal to the partial derivative of h with respect to good x1 divided by the partial derivative of h with respect to good x2. So derivative of this function with respect to x1, so we have x1 raised power 1 upon 2, its derivative with respect, let's write here, so 1 upon 2 will become coefficient x1 and exponent is subtracted by 1, so it becomes minus 1 upon 2. Here we can write 0.2, transposing it to denominator, it will become under root x1, and we have negative here. Okay, here we have minus, so the numerator, it comes out to be 0.2 upon under root x1, that is the marginal utility of good 1 is this very stuff, divided by the marginal utility of good 2 is the derivative of this function with respect to x2, derivative of x2 is 1. So here you can see the MRS between x1 and x2 depends only on one good, that is, and we have minus here because of the negative relationship between good 1 and good 2. When one is increased, another we have to decrease to obtain a certain level of utility. That is the the essence of the utility, the marginal rate of substitution. Okay, the rate at which we are we are increasing one good by decreasing another good, that's called the MRS. Okay, and it has the negative value obviously. So here you can see MRS is this very stuff. Is it equal to this minus 0.5 under root x1? No, it is only this very stuff. Okay, so this was how do we calculate the MRS. Then the second, so this is not correct at all. It was not correct in the first place when we got the MRS equal to -2, but here it was -1. But I was just trying to explain all the things here, all the intricacies of this very question. Now the next option tells us if price of good 1 is equal to price of good 2, then utility maximization problem with utility function f has a corner solution. That means this function has corner solution when the prices of the two goods are equal to each other. And let us try to find out. Okay, so for utility maximization, what we need to do, we want to maximize the given utility function, which is equal to 4x1 plus 2x2 subject to the budget constraint, that is price of good 1 into units of good 1 plus price of good 2 times units of good 2 should be equal to the total income of the consumer, let us say M. Given this utility function, so what will we do? We will compare the MRS and the price ratio, that is price of good 1 upon price of good 2. MRS, and if I draw it here, so we have a linear downward sloping isoquants indifference curve. We have x1 on this side, x2 on this side. Okay, let us say this is our indifference curve. And what is the slope? And MRS denotes the slope of indifference curve. We got this slope of indifference curve is -2, but we take here absolute value. So we got the MRS is equal to 2, that is the slope of indifference curve. And what is the slope of isoquants line? Since P1 is equal to P2, can I write this as P1 upon P1, which is equal to 1? That is the slope of budget line is 1. Okay, so what happens when we have linear utility function and we have the slope of the budget constraint? Here what we can see, the slope of indifference curve in absolute values is greater than the slope of the budget line. So our endeavor is with the given budget. So okay, so let us say this is our budget line. Okay, it is slope is 2. The slope of the indifference curve, the slope of budget line is 1. Sorry for the mistake. Slope of the indifference curve is 2. That means our indifference curve will be steeper. So with given budget line, we want to maximize our utility. And let us draw, let us say this is the line which is steeper than this. So let us say this is IC1, but we want to maximize our utility. Let us take another indifference curve. It will intersect like this. And let me fix it here. So we want to reach to the highest possible indifference curve, and in this case highest possible indifference curve will intersect the budget line at x-axis. When the slope of the indifference curve is greater than the slope of budget line, we will get a corner solution at x1. That means in this case what is happening, since slope of the indifference curve is greater than slope of budget line, we get a corner solution. That means we consume x1 will be equal to the total income of the consumer divided by the price of price of good 1, and we consume no units of x2. So here we get a corner solution. Corner solution. And at times it can happen that the slope of the indifference curve is less than the slope of budget line, and at that point what will we have? Let us say this is no one is working this time, no marker at all. So you can easily check. Let us say if this is our budget line, and if the slope of the indifference curve is less than the slope of budget line, let us say like this. This is the indifference curve 1. Second, we want to reach to the highest possible indifference curve, and in this case, when the slope of budget line is greater than the slope of the indifference curve, in this case, consumer will consume all units of good 2. That is, x2 will be equal to m upon p2, and x1 will be equal to 0. Okay, all depends upon the slopes of the two curves here. Okay, so in this case the question was telling when if P1 is equal to P2, then the utility maximization problem with a function with utility function f is corner solution. Yes, we got the corner solution here. That's true. So this statement is true. Now we have the second, rather the C part tells us if income is 100, let us say income is 100, and what we are being told, price of good 1 is equal to price of good 2, which is equal to let us say which is equal to 2 here. Then the utility maximization problem with utility function g, the sum of optimal values of x1 and x2 is equal to 50. We need to find out whether it is true or not. And let us see here. So we have the main utility function. So g is equal to minimum of 4x1 comma 2x2. Okay, we want to maximize g subject to the budget constraint, that is p1 x1 plus p2 x2 should be equal to the income of the consumer. So price of good 1 is 2, so we have 2x1, price of good 2 is also 2x2 is equal to income is being given us as what is the income given? 100. Then if I divide both sides by 2, we will get x1 plus x2 is equal to 50. Okay, we want to maximize this utility function subject to this budget constraint. So in case of main utility function, how do we find the optimal values? We equate the terms that are in the brackets with each other. Okay, so optimal requires that we equate whatever is in the brackets, that is 4x1 with 2x2. That means x1 will be equal to 2 upon 4 is 1 upon 2 x2. Then what we do, we simply plug the value of x1 into the budget constraint. That means x1, the value of x1 is x2 upon 2. Okay, so I write in place of x1 is x2 upon 2 plus x2 is equal to 50. So this is 2x2 plus x2 is 3, x2 divided by 2 is equal to 50, which gives us solve for x2. So x2 will be equal to 50 into 2 is 100, 100 upon 3, that will be the optimal bundle of good 1. And to find out the value of x1, simply plug the x2 is equal to 100 upon 3 in this equation. So we have 1 upon 2 in place of x2, we got 100 upon 3. So 2 ones are 2. Okay, wait a minute. So this becomes 100 upon 3 here. Okay, fine. So we got here 50. That means we got 50 upon 3. That is x1 is equal to 50 upon 3, x2 is equal to 100 upon 3. So the sum of optimal bundles should be equal to, let us see, x1 star plus x2 star comes out to be 50 upon 3 plus x2 is 100 upon 3. Denominator is same, we can add up the numerator. So 100 plus 50 is 150 upon 3, that is 3 ones are, that comes out to be 50. So when income is 100, this very step, the sum of the optimal values is in fact 50. This statement is correct. Now next statement, rather the next statement, we need to find out what is, whether it is correct or not. For this, let me rub these things. I have explained the 3 terms. Let us explain the last one. So we are being, so P2 is equal to, what is this? I guess it was 5,000 here. Now we have the H utility function. So we want to maximize H is equal to under root x1 plus x2. This is quasi-linear utility function. So such that price of 1 times units of good 1 plus price of 2 times units of good 2 should be equal to the income of the consumer. So price of good 1 is 5, x1 plus price of good 2 is 5,000, x2 should be equal to the income of the consumer. Okay, we want to maximize this utility subject to this budget constraint. As I told you, this is a quasi-linear utility function where the MRS between the two goods depends only on one good, and that very good is actually an increasing function. That is, the derivative of that very function is greater than 0. Okay, now how do we solve a quasi-linear utility function, and what is the intuition behind the quasi-linear utility function? Let's see here. So first we calculate the MRS here. What is MRS? Marginal utility of good 1 upon marginal utility of good 2. We have calculated it. Okay, so MRS we got, earlier we got the MRS is 1 upon 2 under root x1. I am taking this in absolute values. Okay, and what is MRS is we got? We know that the first order condition for optimality requires we equate MRS with the ratio of the prices, that is P1 upon P2. Okay, so let us solve this. Here you can see we got MRS is in only one good. So we have 1 upon 2 x1 raised power 1 upon 2 is equal to price of 1 upon price of good 2. Okay, so we will get reciprocating both sides, we will get twice x1 raised power 1 upon 2 is equal to P2 upon P1. That gives us x1 raised power 1 upon 2 will be equal to P2 divided by twice P1. Taking under root 2, it will become square here, so x1 will be equal to P2 square divided by twice, no, 2 2s are 4, 4 P1 square. I will explain all this stuff, bear with me what I am trying to do here. Here you can see x1 is independent of income, means it is a necessity good. It does not depend upon the income. Here you can see I am saying we got the demand function for good x1 is independent of income. Okay, loosely speaking here. Then what is meant by this? For that, let us first plug the value of x1 into the budget constraint, and let me put it in this budget constraint for making more sense here. So we have P1 into x1 is P2 square upon 4 P1 square. Then we have plus P2 x2 should be equal to income. Okay, here 1 P1 will get cancelled, so we will get P2 square divided by 4 P1 plus P2 x2 is equal to m. That gives us P2 x2 will be equal to m minus, transposing this, it will become P2 square minus 4 P1. Doing cross multiplication here, so we will get 4 m P1 minus P2 square divided by 4 P1, and if I transpose, so we have x2 will be, if I transpose this P2, it will get multiplied here, it will become P2. So let us see what exactly as I was trying to explain here. Here we have seen for the quasi-linear utility function, what is happening when we take the MRS. MRS is the function of only one good, that is the, here we have seen the MRS is a function of only good x1, and also we have seen the demand function for good x1 is independent of income, so no income, but the MRS of good x2, rather the demand function for good x2, here we have the income. Now when will we consume the units of good x2? Okay, only when it should be greater than 0, or let me explain it here. So x2, when x2 is when x2 is less or equal to 0. Okay, let me explain it here. So to consume x2, this whole should be equal to, it should be greater than 0. Okay, what I am trying to explain here, we will be consuming x2 if the value of x2 is greater than 0. And when will be it greater than 0? Let us see here. So if the numerator is 4m p1 minus p2 square, if it is less than 0, this whole term will be, okay, if this term is, the numerator term is less than 0, so x2 will be negative, x2 will be negative consumption we don't do, that means x2 will be then 0. That means we will be only consuming x1, and how many units of x1 we will be consuming, that will be equal to the income of the consumer divided by price of x1. Also another case can be when 4m p1 minus p2 square is equal to 0 if the numerator is equal to 0. In this case also x2 will be equal to 0, so x2 will be equal to 0, and we will be consuming only x1, which is equal to m upon p1. And at times it can also happen that 4m p1 minus p2 square is greater than 0. In this case, what will we do? We will be consuming this unit of x1. That means x1 will be equal to this p2 square divided by 4p1 square, and the value of x2 at this point will be equal to, x2 will be equal to this equation, 4m p1 minus p2 square divided by 4p1 p2. Why I am saying this all stuff here? Let me explain it here. Okay, the thing is, if I draw the angel curve of this quasi-linear utility function, what happens here? If we have x1 on the horizontal axis and income on the vertical axis, what happens? When the income of the consumer increases, consumer consumes more units of good x1. But when income increases, okay, a point comes when the further increase in income does not increase the units of x1 that the consumer will consume, and we will have this kind of angel curve in this case. So further increase in income will not change our consumption of x1. And x-pen, you can think of, let us say, sugar. Okay, so initially when our income increases, we increase the units of sugar we consume. But when our income increases, let us say fastly, or when our income increases, a time comes that we don't increase our level of sugar. Okay, at a certain point of time, at a certain limit, I will say, an increase in income will not increase the units of sugar we are consuming. So we can say it's a necessity good, or loosely speaking, it's not the necessity good, or we can say as the income increases, the share of the total expenditure on that very good will decrease. That means, let us say if we have the income initially is, let us say 10, let us say we were consuming, rather let us say we are saying that consumer was giving all income on the share of good x1. That means total expenditure was 100% on x1. Let us say when income doubles, the share on total expenditure on x1 decreases to, let us say, 50. Okay, and again if share income increases to 40, the share of total expenditure on x1 will decrease, let us say, to 20. So as income increases, the share of total expenditure on x1 decreases. This is how do we solve the quasi-linear utility function. The thing I want to make clear here, it all depends upon the numerator, whether we will get a corner solution or an integer solution. If the numerator is, if here the numerator is less or equal to 0, so consumer will consume 0 units of good x2 and all units of good x1. And if the numerator is greater than 0, consumer will get the corner solution. Then x2 will be this very function and x1 will be this very function. And in this question, what is our x1 and x2? So x1 is this very stuff, okay? But what about x2? Let's plug the values here. So x2 will be equal to, so we have 4. What is the income? Income of the consumer is being given as 100. So we have 4 into 100. Then we have price of good one, that is 5, minus price of good x2 is 5,000 square, divided by 4 into 5 into 5,000. And here you can see this will come out to be negative, okay? Since this comes out to be negative, consumer will consume all units of good one. That means m upon p1, that is 100 is the income and price of good one is 5. That means x1 will be equal to 20. But we are being told that consumer will consume x2. That is not the case here. Consumer will only consume x1 units, x1 units which are equal to 20 units here, because the x2 comes out to be negative. The value of x2 comes out to be negative. That does not make sense here, okay? I guess the question is limit as x tends to infinity 1 plus 1 upon x raised power x is equal to, we need to find out the correct option, okay? So we are being given this function, and let me write it here as limit x tends to infinity 1 plus 1 upon x raised power x, okay? Here we cannot evaluate it directly at x is equal to infinity. Why? Because if we substitute x is equal to infinity, in this case it will become 1 plus 1 upon infinity whole raised power infinity, and it becomes in this form 1 plus 1 upon infinity is 0 raised power infinity, which is equal to 1 raised power infinity. We say this is in indeterminate form, okay? By indeterminate form we mean if we get a function in this form, that is 0 upon 0 or plus infinity upon plus infinity, or minus infinity upon minus infinity, infinity minus infinity, 0 raised power 0, or 1 upon infinity, or we simply get infinity raised power 0. These are all called the indeterminate forms. And here you can see if we directly substitute x is equal to infinity, we will get indeterminate form. So then how do we solve this question? Let's find out. So we do one thing. Let y is equal to this limit as x tends to infinity 1 plus 1 upon x raised power x, okay? We equate it with y, then we take natural log on both sides, that is the ln of y will be equal to limit of x tends to infinity of ln of 1 plus 1 upon x raised power x, okay? Then what will we do? We can rewrite it in this fashion, limit as x tends to infinity, so this becomes x ln 1 plus 1 upon x. From the law of logarithm, if we have ln of x raised power n, it is equal to n ln x, okay? Exponent becomes coefficient. So I can rewrite it in this fashion also, limit as x tends to infinity ln of 1 plus 1 upon x divided by 1 upon x, okay? So if I reciprocate it, it will become this very function, x ln 1 plus 1 upon x here, okay? If we plug the value of x is equal to infinity here in place of x, so the denominator will become 1 upon infinity, which is equal to 0, and division by 0 is not allowed. So what will we do? we apply the L'Hopital's rule here. Okay, L'Hopital's rule. And what exactly does this rule tell us? It simply tells us, if we have a function, if limit of as x tends to a of a function f of x is equal to 0, and if we have another function as limit x tends to a of g of x and it also is equal to 0, then limit of x tends to, as x approaches to a, of f of x upon g of x. Okay, when we divide these two, it will be equal to the first derivative of f of x upon the first derivative of g of x. That means f prime x upon g prime x. And if it still remains in indeterminate form, we take the second derivative till we get it in a determinate form. Okay, simple stuff. If we have two functions f of x and g of x, and x approaches to a in both the functions and they are equal to 0, when we divide these two here, you can see it will become 0 upon 0. Then what we do, we simply take the derivatives till they become in determinate form. Okay, so here what will we do? We will take the derivative of numerator and denominator separately. That means limit at x tends to infinity. What is the derivative of ln 1 plus 1 upon x? Its derivative is simply equal to 1 divided by 1 plus 1 upon x from the law of the logarithm times the derivative of d upon dx of 1 upon x, using the chain rule here. So it will become 1 divided by 1 plus x into the derivative of 1 upon x is minus 1 upon x square here. Okay, so the derivative of the numerator, what will we get? Here it is 1 upon x. Okay, so it will become 1 divided by 1 plus 1 upon x times minus 1 upon x square divided by, similarly the derivative of 1 upon x will be equal to minus 1 upon x square. And here we can cancel these two terms, which gives us, so if we write it in this fashion, that is ln of y will be equal to limit as x tends to infinity, we get here 1 divided by 1 plus 1 upon x. Now we can evaluate it at x is equal to infinity. That means ln of y will be equal to 1 divided by, substitute x is equal to infinity here, we get 1 plus 1 upon infinity. Okay, which is equal to 1 divided by 1 plus 1 upon infinity is equal to 0, we get it equal to 1, which implies ln of y will be equal to 1, taking exponent exponential on both sides. That means e raised power ln of y is equal to e raised power 1. This natural log and exponential gets cancelled. That implies y will be equal to e. So the limit as x approaches to infinity will be equal to e here. The question is, a manufacturer producing hats has the following information regarding cost of production of hats. That is, when one hat is produced, total cost is 4, and when 2 units of hats are produced, the total cost is 13, and when 3 hats are produced, total cost is 32. If the total cost function is of form, that is the total cost function is a function of output which is equal to aq square plus bq plus c, where a, b, c are constants, then the value of total cost when 4 hats are produced, that is when q is equal to 4, we need to find out the total cost. When 4 units of hats are produced, we need to find out the corresponding total cost. Okay, so let us write what we are being given. We are being given total cost is equal to a q square plus bq plus c. This is our total cost. Now when output is 1, and we will write it here, when q is equal to 1 in this equation, then this equation will become a into 1 square plus b into 1 plus c, that is we will get a plus b plus c is equal to, what is total cost when one hat is produced? It is equal to 4. Okay, similarly, and I will write it here, when q is equal to 2, so what will be the total cost? So aq square, that is a into 2 square plus b into 2 plus c. Okay, so this becomes 2 to 0, 4a plus 2b plus c. Okay, so second equation will be 4a plus 2b plus c, and what is that then the total cost? It is equal to 13. Okay, similarly, and let me rub this out, when q is equal to 3, then what will be the total cost? That is a into 3 square plus b into 3 plus c. So this is 9a plus 3b plus c. So we write it here, 9a plus 3b plus c is equal to, and correspondingly the total cost is 32. Then we need to solve for when q is equal to 4. Okay, what will be the cost when 4 units of hats are produced? So we can only find the total cost when we know the value of the constants here. Okay, that means we need to solve these 3 systems of linear equations for a, b and c. For that, what will we do? First thing is we write the given system of equations in matrix form, that is a x is equal to b. Okay, and I will explain what is a, b and c. So a is the coefficient matrix. Okay, so let me see if I am inside the space. Yes, so the coefficients of a is b and c is denote the coefficient matrix. So the coefficient of a in the first equation is 1, in the second equation it is 4, in the third equation it is 9. Similarly, the coefficient of b in the first equation is 1, here in the second equation it is 2, and here it is 3. And then the coefficient of c are same, that is 1, 1 and 1. This denotes our coefficient matrix. Okay, what is x? X is the solution vector, that is we want to find out the value of a, b and c. It should be equal to the vector of constant terms. What are the constant terms here? That are 4, 13 and 32. Okay, to solve for, to find out the value of a, b and c, first we write the given system of equations in the matrix form in such a way that a into x is equal to b. A is the coefficient matrix, x is the solution vector, and b is the vector of constant terms. Then to solve using the Kramer's rule, first thing is we need to find out the determinant of the coefficient matrix. Okay, since a is, what is our a? Let's rewrite a. So our a is this very matrix, 1 4 9, 1 4 9, 1 2 3, 1 1 1. This is our coefficient matrix. First step is to find out the determinant of this matrix. Okay, how do we find the determinant? Simple thing, we write the first element and mentally delete the row and the column in which the first element appear and take determinant of the remaining elements. Okay, so since first element is this, so we delete this row and this column and take determinant of the remaining elements. So remaining elements are 2 1 3 1. So what is the determinant of this very matrix? 2 3 1 1. You can see, so 2 1s are 2 minus, so we multiply these two elements, then subtract and multiply these two elements. Okay, then we write minus from the formula and write the second element, that is 1. In this case, when we have the second element, we mentally delete the row and the column in which it appears and take the determinant of the remaining elements. What are the remaining elements then? That is 4 9 1 1. Okay, so what is the determinant? That is 4 1s are 4, Then we subtract and multiply these two elements, that is 9 ones are 9. Okay. Similarly, we write plus 1. Okay, first we write plus 1, then we write minus 1, then we write plus 1. So sign changes alternatively. Then we write the third element and mentally delete the row and the column in which it appears and take the determinant of the remaining elements. So remaining elements are 4, 2, 9, 3. Okay, so 4 3s are 12 minus 9 2s are 18. Then we solve this. So here you can see 2 minus 3 is equal to minus 1. We have 4 minus 9 is minus 5, minus 5 into minus 1 is plus 5. Then 12 minus 18 is, I guess 12 minus 18, that is equal to minus 6. Minus 6 minus 1 is minus 7, minus 7 plus 5 is minus 2. Rather, the determinant of coefficient matrix comes out to be minus 2. Okay. Now what we need to do to find out the value of A, okay, and let me write it here. To find the value of A, we form a new matrix let us say A1 by replacing the first row of coefficient matrix, okay, coefficient matrix with the vector of constant terms and take determinant of A1 such that the value of value of A will be equal to the determinant of the new matrix which we form divided by the determinant of the coefficient matrix. Okay, I thought it was necessary to write it here. Okay, now how do we find out A1 then? Let's write. So A1 will be our new matrix, okay, which will be formed by replacing, to find out the value of A, let me repeat it here, we replace the first element of coefficient matrix with the vector of constant terms. So we will have 4, 13 and 32, 4, 13 and 32. We are replacing 1, 4, 9 with 4, 13 and 32, and rest we write same. We have 1, 2, 3 and 1, 1, 1. 1, 2, 3 and 1, 1, 1. Okay, now we take the determinant of this very matrix. So determinant of A1 will be equal to, same thing applies, we write 4. I explained it here how do we take determinant. I will not explain it here. Okay, so we write 4 delete these rows, so we get 2 minus 3, 2 minus 3, then we have minus 1, deleting this row and this column, so 13 minus 1 is 13, minus 32, 32, then we have plus 1, deleting this and this, so 13 into 3 is 39, minus 32 into 2 is 64. Solving this, so A1 will be equal to, so 2 minus 3 is, okay, since we are 2 minus 3 comes out to be minus 1, so we are left with minus 4. Here 13 minus 32, plus, so it is minus 19, minus into minus is plus 19. Then we have 39 minus 9 is 5, sorry 5 14 5 64, let me write it here, 64 minus 39, 14 5 6 that comes out to be 25 but minus. Okay, adding this up, so a1 will be equal to this is 29 minus 29 plus 19, which comes out to be minus 10. Then the value of a will be equal to the determinant of this a2 upon the determinant of the coefficient matrix. So it is here minus 10 upon the determinant of a, we got minus 2. That means the value of a will be equal to, minus minus gets cancelled, so we will get 5. That is, a will be equal to 5. So we are done with a. Now in the same manner, to find out the value of b, we replace the second column of the coefficient matrix with the vector of constant terms and form a new matrix A2, that is. So to find out the value of b, we replace second column of the coefficient matrix. So first column is 1 4 9 1 4 9, and in place of 1 2 3 we write 4 13 32 4 13 32, and then we have 1 1 1 1 1 1. Then we take the determinant of a2. So a2 will be equal to the determinant of a2. By the same logic, we write the first element, delete this row and this column, so 13 minus 32, 13 minus 32, then we have minus from the formula, then we delete this row and this column, so 4 minus 9, 4 minus 9, then we write plus 1 and delete this row and this column, so 32 into 4, 4 2s are 8, 4 3s are 12, so we get 128 minus 9 3s are 27, so 9 1s are 9, 10 11, so we get 117. So the determinant of a2 will be equal to 13 minus 32, it will come out to be minus 19, then 4 minus 9 is 5, minus 5 into minus 4 is plus 20, then 128 minus 17, 8 so we will get minus 11 here. So this sums up to be 9 plus 9 minus 19. Okay, let me see. 20 minus 11 comes out to be okay, we got minus 19 plus 20 and minus 11. Okay, so let me see what happens here. So 20 minus 11 comes out to be 9. So we have, okay, let me see if I have done it correctly or not. It should be equal to 20 minus 11. 20 minus 11 is, so we have minus 19 plus 9, so I guess it is equal to minus 10. So okay, so I was just getting confused about these numbers. Then the value of b will be equal to the determinant of a2 upon the coefficient matrix. So a2 is minus 10 upon minus 2 which comes out to be minus 5. Okay, so rather it comes out to be 5 here, but I have some reservation here. I have done a mistake, I guess, somewhere. Sorry. Let me see. So we have minus 19. Here we have minus 19. Then we have minus into minus is plus 20. Okay. Then we have plus 11 here. Okay, plus 11 I guess here. So what will we get? 20, and it comes out to be 31 minus 19. So 11 minus 9 is 2. Okay, why I'm getting stuck here, I don't know. So 2 minus 1 is 1. So actually we are getting 12 here. Plus 12. I hope I have done the correct calculation here. So then the value of b will be equal to a2 upon a. So a2 is 12 upon minus 2. Okay, should the value of b be negative? What we are being told here, a, b, c are the constants, so we are not being told whether they are integers or whole numbers. Okay, so this comes out to be minus 6. Okay, simple thing. To find out the value of b, we replace the second column of the coefficient matrix with the vector of constant terms, and then take the determinant of this very matrix, and to find out the value of b, we divide it by the determinant of the new matrix with the coefficient matrix. So the value of b is equal to minus 6. By the same logic, we can find out the value of c by replacing the third column of the coefficient matrix with the vector of constant terms. Okay, and then forming a new matrix A3. Okay, so by the same logic, but we don't need here because we got two values a and b. We can find out the value of c very easily. But to explain it, to find out the value of c, we replace the third column of the coefficient matrix with the vector of constant terms. The value of c will be equal to a3 upon a. Okay, but we are not supposed to do that very calculation. You can check it by yourself. Now what we are being given here, a plus b plus c is equal to 4, and we know the value of a and b here. That means, so in place of a, I will write 5. In place of b, I will write minus 6. Plus c is equal to 4. So 5 minus 6 is minus 1, plus c is equal to 4, or c is equal to 4 plus 1, or c is equal to 5. Okay, so since we have found out the values of a, b and c, now we can find out the cost of producing 4 units. Then when q is equal to 4, sorry for my English, so when 4 heads are produced, then what will be the total cost? As we know, the total cost is a function that is a q square plus b q plus c. So we can write, in place of a we have 5, q square means 4 square, plus b is minus 6, let's write it here minus 6, then minus 6, and q is 4, plus c is 5. Okay, so this is 4 4s are 16, 5s are 16, 5s are 5, 6s are 30, 5 1s are 5, 6 is 7, 4 4s are 16 and 5, so it comes out to be 80. Okay, so we have 80 minus 24 plus 5, so this is 85 minus 24. So what is 85 minus 24? 85 minus 24 5 is 8 is the 61. Okay, so total cost of producing 4 units of heads will be equal to 61. So here it should be 61, or rather here it should be 61. Same thing here. I hope I make myself clear in this video. Thank you.